For services, the black background and large font size are used to avoid eye pain. Students can make a script themselves using the drill in the video. Increase the concentration of learning by utilizing animation. Shell script lectures are helpful too. Please look at the screen. I will meet you in the video. Thanks for watching. File name or directory name cannot exceed 255 characters. Alphabet uppercase, lowercase numbers, periods, underscore, hyphens are possible characters. Uppercase and lowercase letters are strictly distinguished. Therefore, uppercase A and lowercase a are acknowledged as different letters. Meta characters can be treated like literal characters using the backslash character. We call this escape. Use quotation marks when a file name or directory name must contain spaces. Only then can file or directory names contain spaces. File directory names have a period at the beginning of the file name. So, if you want to hide a file or directory, put a period in front of the file name path. Let's go to the following directory path. You can see that the directory path has been moved well, but we need to know how to make it easier to move the directory path like this. So let's see how to easily enter and navigate to the directory path. Let's move to the default working directory and move to the directory named USR local include in the root directory we moved earlier. The tab key makes it easier for us to navigate the directory path and saves the typing effort. As you can see, when moving through the directory path, you can enter a bit faster by pressing the tab key. So we can move the directory path more easily. This function can be used in addition to the following purposes. Assume that you have following file or a path with a large number of characters. Then we can also enter this easily and quickly. You can enter it quickly and easily using the tab key. We call this the Linux autocomplete feature. It is always a method to be used in entering path names in future classes, so it would be good to practice until you are familiar enough. Please use the autocompletion function when entering both path name and file name. The Linux top-level directory is called root directory. We always type the following command to go to this root directory. The screen you see right now is the root directory screen. So we can go to the top-level directory like this. If you want to see the contents of the top-level directory, you can always use the ls command. If you look at the subdirectory path in the top-level directory, you will see a directory called bin. The bin directory is where there are many executable commands. You can see that there are many commands called basic commands in the following path. The top-level directory also has a directory path called sbin. There are also many commands that can be executed here, which is characterized by many commands used by the root user with system privileges. There are more executable commands in addition to the two directories shown now. There is a directory called usr bin. In this directory, many applications installed in the Linux operating system are located by default and also exist as commands. Finally, there is another directory with executable programs. This is a directory path called usr local bin. The application is located when USR local is selected instead of USR as the installation path of the application. That is, commands may exist. In the top level directory, there is a directory called lib. In addition to the basic library, there are many program libraries used by the application program. In addition to the one you can see here, the Linux library has one or two more paths, and the directory path is usr lib. The executable programs and the libraries of the application are installed here. Also, there is a usr local lib directory under the top level directory. This path is also the path to the library installed when the application was installed. The top level directory has a directory path called dep. There are many files in this directory called device files. These files are Linux special files. Through the device file, a lot of Linux's installed hardware will work. Applications use this device file to access hardware. There is a directory path called etc. in the top level directory where environment files are gathered. In Linux, files that function similar to Windows registry are called environment files. Each application program has its own environment file, and using this environment file, the application program's internal settings and system-related information are extracted, and the program operation is executed accordingly. The top level directory has home directory. Many users have their own home directory by default, which is often referred to as working directory. When individual users log in, by default, they go to their home directory, that is their working directory, and perform various necessary tasks. Create, delete, and modify directories at will without creating files, creating directories, or worrying about ownership. The top level directory has a directory called var. This directory contains files that store system-related information. We often refer to the system log as a log file for monitoring the operating of the system. The directory called the log is in a directory path named log on the var, and many log files are in this path. Ubuntu Linux has a log file called syslog. When important kernel events occur during system booting, the information is recorded in this log file. Users and system administrators view the internal state of the system through this log file. Finally, in the top level directory, there is a directory called usr. This directory is the same Linux directory as purpose of the Windows program files directory. This directory is valuable as the directory where many Linux applications are installed. Many application programs install binary programs in a path called bin under the usr directory. The necessary library and system header files are placed in the lib and include directories respectively. It's good to remember that the program installation can also be installed in the usr local directory in addition to the usr default directory. So far, we have learned about the directory structure of Linux. Moving directory paths in Linux is always a thing, so we need to study the principle of this directory path movement. Let's take an example of the basic form of moving a directory path. Let's say we have a US local include directory. Then, we write the path name after the top-level directory path expressed by /, which is the top-level directory as follows. We call this path. The directory path you're looking at now starts with / character, and that's how the directory path is expressed in absolute or proof path. On the other hand, in addition to this expression of absolute path or proof path, there is also relative path expression. As you can see, it is in the US local include directory. We can modify this directory path and move it to the new directory path. US local, this is also called full or absolute path. Of course, it will work fine without any problem of moving a directory path. Then, we'll move to the directory called include based on the current path. The way to go is to enter the proof path of US local include and go. But we are going to move this directory path in a way called relative path. If you use the relative path expression method to express subdirectories based on the current directory, you can move the directory by entering a period, / and include, indicating the current directory. This expression is called the relative path. The feature of the relative path is that the / is not visible at the beginning of this path name indicating the path. Path names starting with the / are called proof path or absolute path. Conversely, if it doesn't start with a /, you can think of it as a relative path. Now, let's enter whether the directory change works well even with the relative path. As expected, you can see that the directory moves well. Relative paths are used to move subdirectories within a specific directory, as you can see, but even when moving to US local corresponding to the parent directory based on the current directory path, we can enter it in a relative path to move the desired directory. If you enter two periods, it is a method of expressing a relative path used when moving to a location called the parent directory, or the parent directory of the current directory. If you type in the terminal, you can see that the directory is moved as expected. In a similar way, type two periods of /. You can also enter a period twice to move to the parent directory of the current directory, i.e. the grandparent directory. Since the current path is in US local, it will go to the top level directory after executing this command. Again, you can see that the directory has been successfully moved to the top level directory, and we call this a relative path. Creating a directory in the desktop directory. You can see that the directory is well created like this. Go to the created directory dir1. Create a file with the following string, hello world as helloworld.txt. You can also see that the file was created. If you look at the file detail view command, unlike the ls command, you can check the detailed information of a directory or file through the file list detail view as follows. You can see the contents displayed on the screen are slightly different for both directories and files, and the difference is shown on the far left. From now on, I will explain the contents of screen displayed as a result of executing lsr, command to view detailed file list. The leftmost column is what we call the file type. In the case of directories, it looks like a D in this part. We can see from the output of this content that this item dir33 currently visible is directory. Otherwise, If it is marked with hyphen, it indicates that it is archive file. This hyphen confirms that the current hello world.txt file is not a directory. That is, you can confirm that it is normal file. The file type field will show symbolic links, device files, WAP pipes. Next to the file type field you will see what is called file access permission. Each field has an octal form, but it's hard to see that this is octal form from our eye. Octal numbers are represented by 3 digits. Numbers range from 0 to 7. The corresponding octal number can also be expressed in binary. The number 0 in octal is represented as 000 in binary, and the number 7 is represented as 111 in binary. The letter R indicates that the file or directory has readable access permission. The letter W indicates that the file or directory is writable. The letter X of the alphabet indicates that it is executable for files. In the case of a directory, it indicates that the directory is readable. After all, RWX represents one full file access, directory access. You may see RWX appearing more than once, many times, because RWX displays the user's access permission. RWX, shown right on the right, displays the access permission of user groups called groups in Linux. To the right of that, users and other users who don't belong to either group. We call these users other. In the case of this other, the directory is readable and not readable, but can be built. Symbolic hyphens used here are used to indicate that you do not have appropriate permission. In summary, access permission are defined as owner access permission, group access permission, and other user access permission, and they are displayed in the file list. The numbers you see right now are called hard links. Currently, in the case of a file called hard link, the expression is shown as 1. The number 1 means a number of links pointing to a file called hello world.txt in the current disk device file system is 1. However, the number 2 used in the directory shows that there are currently 2 directories in the directory named dir22. You can check it yourself. If you look at the contents of the dir22 directory, the period and slash mark the directory that actually represents itself is the current directory. And you can see 2 periods indicating parent directory or parent directory. Every directory always has 2 directories by default. Even if it's an empty directory, one is subdirectory and the other is parent directory. The name user as shown in the view details command represents the name of the owner of the current directory or file. The user shown on the right has different meaning, even though it has the same name, but it is user as group name. The number 4096 is basically 4096 in the case of a directory, but in the case of a normal file, is the size of the file in bytes. If you look at the contents of the file hello world.txt, a total of 12 characters are used, including hello world and 12 space characters and 1 new line character, so the total size of the file is 12 bytes. The currently selected contents shows the most recent modification time information on the screen, not the initial creation time of the file. The content shown on the right side of the time information indicates the directory name in the case of a directory and the file name in the case of a file. There are 2 types of link file formats in Linux. One is called the symbolic link and the other is called hard link. As you can see, the hello world .txt file is hard link file. As shown on the screen, the number 1 indicates the number of hard links in the file, and it is the current hard link of hello world.txt. This hard link can have more than one, and if you look at the current file, the string hello world is contained in this file. We can make this hard link additionally if necessary. You can do it using the command ln. Let's create an additional hard link right away. Create a link similar to the name hello world.txt. For easy viewing, let you enter HD at the end of the file. Then immediately hard link with a similar name would have been created called hello world, and we can check it like this. Apparently, it is true that this file looks nothing different from the original hello world.txt. In fact, it can be seen that contents of the file are the same, and it is difficult to tell whether this file is the original Pine or another hard-linked file unless we check the name of the file. Whenever hard-linked file is created, it is called the number of hard links, and the number of detailed listings in the file is always telling us that the number of 2 is that there are 2 links pointing to the original in a file with a string called hello world. Remember that you can't create hard links to directories. In the case of directories, of course, they won't be created, but I try to make a hard link anyway. As I mentioned, there is an error message stating that the directory is not hard linkable and not actually possible. From now on, we will look at symbolic links. Let's create a symbolic link. For symbolic links, you just use the same ln command, but just type s as an option. Hello world will also create a symbolic link with a similar name. At the end of the file name, it seems to easily identify the symbolic link name. Then we can immediately see the symlink file created. In the case of a symbolic link, it is marked with L character in the file type field so that you can easily confirm that this is a symbolic link. In addition, it is information to indicate which file the original of this symbolic link file is. And you can see that the contents are displayed on the right side of the file name output result. A symbolic link is actually a link file that points to the original file and is distinct from a hard link file. However, hard links and symlinks can be confusing. If we just remember that a symbolic link is similar to a shortcut file in Windows, then to what extent we can distinguish between a hard link and a symbolic link? It can be said that symbolic links can be created as many times as hard links are similar. However, symlinks differ from hard links in the basic file size. Symbolic link is a single file like a regular file. Symbolic links are files whose purpose is as means of pointing to the original file. However, just as the original file has a hard link format, a hard link is the same as the symbolic link in that it is link style pointing to a single source. It's different from the terminology and actually has different structure than a symbolic link. Assuming that there is corresponding file containing the string hello world on the disk device, this file is represented by name hello world.txt. Remember, this is also hard link. However, you can create more than one hard link. You can add hard link in the following way. 2 links point to one original, and the symbolic link is not a concept that directly points to the original file hello world. If you understand that it exists in the form of a single link file that points to the hard link hello world.txt file itself called hello world, you can understand at once that hard links and symbolic links actually have different meanings. The echo command is a command in charge of displaying the screen compared to the famous strange printf. When we want any string to appear in the terminal, we can use the echo command right away. As shown below, the output result of a screen called Hello World was made possible by using the echo command. If you want to enter a lot of space characters in the string called Hello World and print the contents, you must enter the Hello World quotes corresponding to the current command string at the beginning and end to display the desired number of blank characters. If you don't enter the quotation marks, you will see the following result. The reason for this output is that in the Linux shell, the space character acts as a separator between words and words, commands and options and arguments. Therefore, there is more than one space character, but only one, but it is used only as a separator. Contrary to the user's intention, multiple white characters won't very different from using one white character as a result. As a result of showing only the effect of one separator, only Hello World was printed. As you have seen before, if you want the space character to function as a buried character, not as a separator, but as a space character, you must put quotation marks together. Basically, you can use single quotation marks as well as double quotation marks as quotation marks. There seems to be no difference in use between double and single quotes, but you will see big differences in the use of double and single quotes in future lessons. Echo command has options by default, among which is the E option. This option can be said to be beneficial when you use special characters in screen output or when you are using things like control characters. Let's see. I have a string like this. If you enter one or more new line characters and enter option E, you can see that we have as many line breaks as you want. You can try the same example without the options. You can see that it doesn't actually function as control character. So, examples of escaped special characters include so-called line breaks, horizontal tabs, vertical tabs, etc. And when you use special characters that make an alarm sound like a lot, do not forget to use the following options for the effect to appear. You will see a beep sound every time you run it. If you enter the N option with the echo command, you can see that line breaks are not handled compared to when this option is not used. When using special characters, make sure that the following options are so available. Finally, the echo command can also be used for the following purposes. Just as you can see the file list with the ls command, you can also see the same file list with the echo command. There are files and directories in the current path as follows. If you use the echo command, you can see that the file list is displayed the same as when you actually type the ls command. If you look at the following example, you can clearly see the difference between the output of the file list using the echo command and the ls command. If you enter ls after moving to the shell cmd directory in the desktop directory, you can see that each word, file name, and directory are properly formatted as shown below and output nicely using appropriate type characters. If you expect and execute the same command output using the echo command, you can see that the screen output is very different. You can see that files and directories are mixed and separated from each other only by blank characters and are displayed on the screen. Readability is inferior compared to the existing ls command, but it has its own advantages. So if you use this echo command to be the file list, since all lists are separated from each other by only one space character, extracting the desired substring from a list like this is called the substring, which is useful when doing this. So, when we do the string manipulation of the file list inside the shell script file, we will study in the future. We will find that the ls command is good, but the echo command is more convenient and widely used. Finally, I summarize. First, the echo command is basically used for the screen output. Second, the fact that you must use quotation marks when necessary. Third, remember that the echo command is not only used for screen output, but is also used to print a list of files. Commands may have options after the command. Therefore, if you enter ls, the default list of files will be displayed, and the default format will be displayed. Only simple file and directory names can be checked. However, if you enter a detailed list view option code and after the ls command, you can see the result of the detailed list view command of the ls command. As you can see, Linux commands can have options. With this option, default form is followed by space character, followed by hyphen, followed by alphanumeric character. Options can be lowercase or uppercase letters and numbers if necessary. And in addition to the command option, the command may have argument at the end of the additional information. In the following case, it is command to print the contents of the USR directory. These are called commands, options, and arguments, and these individual contents must all have spaces as separators. Commands basically use hyphens when writing options together. Knowing that there are times when we write options with one or two hyphens, we may not panic if we see something similar in an upcoming class. In some cases, you will see only one hyphen, and in other cases, two hyphens as you can see. Functionally, there is no difference in use. Please create a directory like this. And go to that directory. Enter the following. Touch command performs the function of updating the file to the current time if there is file name orange, apple, or banana as follows separated by space character. If the orange, apple, or banana file does not exist, this file will be created as new empty file format. Make sure that 3 files with a file size of 0 are created as follows, and we can delete this created file if necessary. For the delete command, we use the command lm. We can write down the name of the file we want to delete and delete it, but when we delete these files at once, we can do it with a special symbol like this. It's called a glob, but it's actually known as asterisk or star symbol. Also, this character is also used as multiplication operator in C language. In the Linux shell, this star symbol, asterisk, or asterisk is referred to as a glob. Typing rm for glob purposes, including spaces, will cause deletion of all files in the current directory. There are current files named apple, banana, and orange, but since you executed this command, nothing will remain. We found it convenient to use the globe to select all unspecified files, as in this example now, and you will see this open in class later. Navigate to the following directory paths. Try typing like this. As you can see, I'm trying to delete a file, but I'm getting an error message stating that the file does not exist. As you can see, the file does not exist in the current directory, so it can be seen as a natural result. Then I will create this file. Using the command touch, we can create an audio file called Gone with the Wind, and you can see that the file is well made. Notice that the quotation marks are used when creating the current file. It's important to know what happens if we don't put these quotes. Now I will give the command to create a new file called Gone with the Wind without quotes. Contrary to our intention, the result is recognized as a file separated by space character, so you can see that the files are individually created on a per word basis. If this was what we wanted, it wouldn't be a problem, but if it wasn't what we expected, it could be said that it gave the wrong result. So we have to keep in mind that quotes must be used when dealing with files that contain white space through these examples. Quotation marks are not only available for single quotes, but double quotes can also be used if necessary. So, in the current example, since the file already exists, I will not create it again, but it's good to remember that this expression method is also possible. Please start in the following directory. Please take a good look at the screen and enter. Go to a directory called matter. It says Gone with the Wind, which means check if there is corresponding file. Then, to check the details after running and press enter. If you look at it, you can see that it has been moved to a place called matter, and you can see that a file called Gone with the Wind exists. The special symbol used here is a test command that checks if the file is in current path called Gone with the Wind. Apparently, it's special character, but in fact, this command is used as a special function in the Linux shell, which means to test right away. This test command, brackets, is a command for the purpose to determine whether the following content shown on the right is true or false. It has a name called square bracket. These brackets are used as a test function, and you should always put the right bracket together just before the end of the test sentence. Therefore, we move to the directory that the user runs and enter the command. Is there a corresponding file in the current directory, along with the test command? Here we have confirmed that these brackets are commands, and because of the nature of the command, you must separate with the following options and a space character. If you don't do that, and you use this command with the letters that follow, you will also see this error message. Let me remind you once again that the Linux commands will not must have spaces between commands and options and arguments. The brackets corresponding to this test command that you have seen now will be used a lot in the Linux shells if else statement to determine conditions. You will practice in a directory called share CMD on your desktop. Please download the file called the share CMD at the top of the screen and prepare the directory according to the following procedure. Move to a directory called the share CMD. Try typing like this. The command called WC has a function that outputs the number of words in a specified file. Originally, a file called fruits.txt is a file containing words representing the names of 5 fruits. Using the command called WC, I was able to check how many words the file was by writing the option W, which means what. Similarly, you can check the number of lines by changing the following options. You can just count the number of characters in the longest word in the file by putting the option uppercase like this. You can check how many characters exist in the file. As you can see now, WC is a useful command when checking the number of words and letters, the number of lines, etc. This command will be useful when writing shell scripts and other uses in shell programming in the future. The command SIG is a command that generates numbers. Given a starting value of 1 and an ending value of 200, it creates a serial number from the beginning to the last digit 200. You can use the redirection symbol to save the output as a file, and the file is saved under the file name num200. The file is filled with numbers, and we will run a command called tell like this. The tail command is a command for that purpose, which prints the last and the last contents of a file. You can see that it prints the last part of the num200 file filled with numbers from 1 to 200. In particular, if you look at the file output result, you can also check that only 10 lines are being printed on the screen. If we adjust the number, we can adjust the number of output lines as much as we can. If you use the tail command and the option plus operator together, you will see a different result than the one you saw before. In the previous exercise, only the last 10 lines of the file were printed, but if you look at the output now, you can see that it was actually printed from line number 10. By using the plus operator option, you can specify line number to print from desired location to the end of the file. Before looking at another option of the tail command, you can use pipeline to output the result of processing the command by passing the data to the next head command as follows. The last part of the file is output from file 101 of line number num200, and the command code has received the output result and prints only the first 10 lines. Let's see if that actually comes out. From line 101, you can see if a total of 10 lines are output. As expected, you can see that the exact 10 lines from line 101 to line 110, which are part of the file contents, are displayed on the screen. Using this method, you can see that any part of the file can be selectively output to the screen. The tail command also has an option as follows. This option allows you to display the system log file called bar log size log, which is normal system log file on the screen in real time. In other words, whenever there is change in the log, you can monitor the result in real time. When a USB device is plugged into the current Linux machine, a message indicating that the USB is connected will be logged in this log file, and you will see it soon. I will connect the USB. As you can see, when the USB device is plugged in, the log information is updated and the contents are displayed on the screen. If you know that you can track log information in real time by using the following command telf, which system administrators use. When we use the shell, it will be useful if necessary. In Linux, commands are shortened commands like shortcuts, which are called alias. For example, it is called mkdir. This command is used to create a directory. If you frequently use the P option, use the following command to avoid having to write down the P option every time you create a directory. For example, mkdir directory 1, 2, 3. dir 1, dir 2, dir 3. For directories with structured subdirectories within the directory, you must write the P option like this. We have overridden mkdir p with alias mkdir, so this option can be omitted. So if you run it, you can see that dir 1, dir 2, dir 3 was created successfully. Well made, okay? Alias is very convenient for its purpose of use. Let's look at another example. Instead of entering 7 letters called history, it would be nice if we just type H. So, if you just type, you can see the same impact as typing history. You can check all the lists that the user has entered in the past. Alias is a command that provides such convenience. Let's look at another example. There is a program called Minicom. This program is basically a program that connects and uses the random device to the serial terminal. It has some complex options, such as, in this case, it would be nice if we could achieve the effect of entering all the complex commands by simply typing M. You can see that it works as expected. To exit the program, press Ctrl+AX Enter. You can install the Minicom program after viewing the guide subtitle at the top of the video. Basically, it is a program that requires a separate installation that is not installed in Linux, Ubuntu. If you can run it, use the installation method shown at the top of the video to practice after installation. As you can see in the example right away, sometimes we type in TTYSO, but sometimes we may have to type it differently. For example like this, then we have to create a new alias every time to respond to this changing situation. This method is not impossible, but we will think of a more convenient way to use it. It would be more convenient if we didn't do this, and we could type in this way. Here, I feel the limit of shortening the command called alias. Alias can't pass and receive the number 2 as the following. So it's important to understand that aliases are called shorthand commands that are used only as they are given. So it's worth remembering that it's not possible to just modify. There is a way to solve this problem that is an alternative to aliases. You can use something called a function. If so, we can make this function as well, since there shouldn't be a conflict with the old name. I will make the new name mm. You can enter the same to Minicom TTYS handles. So that it can receive the argument. Just enter the following. Be sure to enter a semicolon before closing the braces. I made something called the function like the following, and how to use it is simple. If you enter O after mm, you will get the same result as when we wrote the alias m. So the factor O is passed to mm, and it is replaced using $1 as follows. We experimented with MMO, and we can see that it works the way we want by saying TTYSO. Similarly, we will run it again after ending and pass the argument 1. You may also have noticed that using a function gives you a fairly flexible result compared to alias. We will use alias and function separately in the future, but alias has another disadvantage. Alias cannot be used inside the script file. On the other hand, functions have the advantage that they can also be used inside the scripts. So understand the pros and cons of each and use aliases or functions in the right places. Please check the current path and enter the following command. The pushd command is a special type of command that stores a specified path on the stack. The current path is saved on the stack. I moved to a random path as follows. If you want to go to the previous path from the current path, etc. sidebar, we can go to the old path just by typing popd. If we use parallel commands called pushd and popd, you can save the desired path and move to the saved path. You can use a command called pushd to save the current path when moving to a path for a while. This command can also be nested to store paths. Once again, you can use this pushd command to save and check that the current path, the desktop path is saved. Moved to the sidebar directory. Once again, use the pushd command to save the current path, etc. sidebar onto the stack, and it moves on new path again. Then the directory path has been moved twice, and you can see that every time you run the popd command, it moves to the previous path. When moving between directories, wouldn't you think that you could save the current path and use it well enough to return to the original path if necessary? This is a very useful command depending on your needs. When we simply run back and forth between certain paths, it may be more convenient to use this option with a command called cd rather than this command. If you use the option hyphens on a cd, it is beneficial when you move back and forth easily between directories. As you can see that it moves back and forth between those two paths continuously. It would be nice to move between directories conveniently by using the hyphen option of the pushd and popd commands and cd command. Unlike the echo command, printf allows permitted output. As you can see that the simple number 1 is printed in 2 digits with the reading value of 0. As a similar example, you can try the same number as one as permitted output. Then I think we can guess that printf in C and printf in the shell are very similar. Printf can also be used for the following purposes. In addition to simple screen output, you can store a string named Michael Jackson as variable named region as follows. You can think of the option V here as a symbol for a variable. So a variable named region is created, And this variable's permitted output called microjection is applied so you can see that it was actually output to the screen by the echo command. As you will soon learn, in the shell you can create something called variable. To use the variable, write the name of the variable, write the assignment operator =, and enter the desired string as it is, without spaces. This is called the variable declaration. Likewise, you can declare a variable in printf, but I created a variable name with a special name called legend. When using the created variable, you can access the variable using special characters using $. In the echo command, a $sign is used when outputting variable called legend, but if it is not used, legend is recognized as text. However, when a $sign is attached, this word that appears after the $sign is treated as a variable name. So the character Michael Jackson in the variable name legend is displayed on the screen. Printf is intended to be used extensively as a command to print to the screen along with the echo command. If echo or printf is the command in charge of the screen output, the red command you see now receives input from the user. Enter the following command and press enter. Please enter the number you want. Please enter. The information you enter will be stored in a variable named num. The number 1, 2, 3, 4, 5 stored in the input variable can be checked by the echo command and the variable name with $. Variables have the following characteristics when used. You have to put a $sign to check the contents of the variable. You can use the red command as follows. Enter the following command, press enter, and then enter your phone number. After entering the phone number, press the enter key to save the entered information in the v variable. The variable name does not have to be the name v. It can be any variable name we want. As you can see the information entered. You can check it as follows. Let's look at the following example. We enter a simple query asking if we are 16 years of age or older, but the only ones that can be entered are yes or no. If we are going to enter either Y for yes or N for no, let's press Y first. As soon as you press it, you can see the reaction on the screen. The difference from the practice example that you learned earlier is that you didn't have to hit enter after typing. As you can see, you can also limit the number of characters the user enters. Because 1 is entered, the number of options is 1. So even if the user enters 1 character, no further input is received. And the red command terminates, i.e. terminates. In this user input method, where we simply enter Y and N, this method may be more convenient depending on the situation. Let's look at the following example. The difference is that the silent option -s has been added. If we type Y after inputting, we can see that the input Y is not unnecessarily displayed on the screen. This method is used when we don't want to see what we type. It is a silent option. Finally, you can limit the user's input time. If the user does not respond for 3 seconds after inputting, the query will be terminated after 3 seconds. Please wait at least 3 seconds after entering the following. One option is missing. Add prompt option and run again. Do not enter for 3 seconds. You can see that it automatically ended after 3 seconds. You can show user-friendly and informative interactions through these options, as follows of the red command. The red command will be used extensively throughout the class as a command for user input and up along with echo and printf in the future. In any programming language, determining conditions and creating loops is basic function. Therefore, you can use while loop in shell programming. As you know, loop statements are used to implement something called iteration. Let's take a basic example. Unlike the contents of the previous class, this example has a lot to input. There are many parts to be entered with care, so please enter it carefully while paying attention to things like space characters. When the input is done, I will press enter once. You can see the number shown as the serial number displayed on the screen. Let's analyze the contents one by one with the following command. Basically, a command called printf was used. Currently, there is a message on the screen saying that it will be printed into digit. Actually, the printf command consists of one sentence, depending on how the variable is declared. A variable called no will be prepared in this variable. In fact, you can expect the output to be printed by printf. The variable no has the initial value of 1, and this variable is used in a loop called while loop. While has a logic structure, whose basic syntax is while, do, done. Between while and do there must be command or evaluation expression that means true and false. The decision logic to determine whether the variable no is less than 10 is implemented. Here you can see that parentheses are being used for arithmetic operation we will run in the future. In the sentence of while, do, done, the evaluation is performed first, and only when the evaluation is true, the sentences between do, done are executed. You can see that do, done contains printf and uses the operator that increments the value of 1, which is initialized with the variable value, every time the loop door rotates or runs, as long as true persists, by the operation of the value incremental operator shown in do done. In the second, loop statement no will be changed to value of 2 incremented by 1 to 1. Since the second evaluation is also true, the second printf is also executed, and this loop statement will continue to print printf over and over until the variable called no reaches the value 12. So we ended up seeing the results like this. The while loop starts with what is introduced now and will be seen often in class in the future. Although now we are running that arithmetic operations are or not, I think you will be able to understand more clearly how the example you've seen doing works after we run these topics individually, then the topics for while and then for arithmetic operations. Because the curriculum related to this content that you are learning right now is displayed at the top of the video. If you want to preview the video, you can refer to the link. Let's write a simple script. The script file can be executed only if it has the execution attribute. So use the chmod command to assign the execution attribute. The created hello world.sh script runs fine. The Linux shell provides several ways to run executable files, and we will look at them one by one. First, let's look at the first way to run this file because the script we've created is also an executable program after all. Copy this script file to USR bin in the top level directory. You can see this directory is only accessible with root privileges, so we can copy this file with root privileges. In Ubuntu Linux, when you want to perform the function, enter the command called sudo before the command. Then, when you run it, you will be asked for a password. The password you enter at this time must be root user's password, not the user's password. So, enter the root user password that you know. If you don't know the root user password, you can check the root password through System Administrator, etc., and then continue this exercise. I will enter the root password. I believe it would have been copied successfully and run the script file, but this time I run it by entering the name of the script, not by typing the following. The reason is that the directory called USL bin is public path, so the executable files in this directory do not write down all the path names, and only the actual file name is executable. Explained the first way to run the executable. Let's look at the second method. The second method is to write down the entire path of the file. The current path looks like the following. If you write the entire path of the script file called helloworld.sh in this path, it will run well. As you can see, the second method was to write down the full path of the executable and execute it. Let's look at the third method. The third way is to add the current path to an environment variable called path. Current system environment variables can be checked as follows. How to add current path to this environment variable called path is as follows. If you add current as separated to the existing path environment variable and enter the current path desktop share cmd path correctly without any typos, a new path is created and we can check that the path we want has been added to it like this. When the path is added in this way, you can omit all the paths of the executable files you want to run and run them. Since the path of USL bin that we did previously may have been executed, we will try to run it after deleting helloworld.sh that was copied from USL bin. Delete helloworld.sh under the USL bin path that was previously copied. Since it has been deleted, we can now believe that the helloworld.sh script we will run is not helloworld.sh in USL bin. Try to run. You can see it's running well. This is thanks to the path name we added. So what I explained now was how to run an executable file using a path. The last method is probably the one you already know well. This is method of displaying and executing what is said to be in the current path in a relative path manner. When executing a file in the current path, we may forget to type this slash, but remember that when executing a file in the current path, we need to include the forward slash. This was the last and fourth way to run the executable. We can choose any way we want. The shell is a command interpreter, an application that provides the ability for users to interactively issue commands to the operating system will execute commands in batches. Think of the shell as providing a way for users to interact with the system. The Linux operating system basically has the most core part of the operating system called the kernel. The kernel basically operates the hardware and supports those system functions, including the hardware to the user or application in the form of a service. The shell is the main body that connects users and applications to the core of the operating system, constantly interacting with users. Requests generated by users or applications are transmitted to the kernel so that users can receive necessary kernel services. It provides other information and provides better service to applications running on the operating system. These shells are historically known as Bourne shells that have been used since the days of Unix. There are even the most recently popular G shells and the Bash shell, which has been supported since the beginning, is the most popular in the Linux operating system. In shell script education, we are basically teaching based on the Bash shell as the basic shell. It can be said to have a long history as the most popular shell. Basically, those shells have some degree of compatibility, so scripts that were executed in the shell can be executed in the Bash shell without any special manipulation. Also, many commands executed in the Bash shell can be executed in the G shell. On the contrary, however, we have to remember that the most recent shells may not run on old Bourne or Bash shells. Any information entered by a user or executed in the application's terminal is interpreted and executed by the Bash shell, which is the default Linux shell. Therefore, we always feel the existence of the shell through this training and run the correct usage of the shell while running the basic syntax of the shell. Go to the next pass. The script file that has already been created is shown. This script file can run fine without any manipulation, but edit the following content to existing script file to find out the meaning of the additional content. Try typing the following at the beginning of the script file. What you entered right now is called shebang or hashbang. A program path called the winbash is created under the root directory. You will see an exclamation mark to the right of the word sharp or hash. We refer to this as shebang or hashbang, including the path of the sharp exclamation mark bash. Its meaning can be said that it acts as a translator that actually reads and executes the script file currently being edited. It can be said that the bash program of the path written in shebang and hashbang is the executioner of the script currently being edited. If we enter the command rm in the path called bash in the following path, currently executing this script is command called rm. Normally, when writing a script file, you can enter shell commands in shebang. The current script is basically based on a shell called bash, so unless there's anything special, I write shebang like this. I will try to run the modified content once, but after saving it, it will be executed in the following way. Currently, the main agent of this script execution will be a program called bash, written in shebang. The actual path to the bash program is located under the top-level directory as being bash. If the bash path on a system is in different path than what is currently visible, this script file may not be executed at this time. Therefore, We must remember that there is another method besides the following method of writing shebang. If you replace shebang with the command usl vim env and type the following, the script file can be executed normally even if the path of the program called bash is not under the bin directory, under the top level directory, which is the default path. Therefore, it is better to remember this method as you see now, which is a better way to write the shebang. If you type the ps command in the terminal, you can see that a process called bash is always running in the background on the current terminal. The purpose of this program called bash is to help this program accept and execute all commands we type in the terminal window. The command corresponds to all commands that can be entered in the terminal, so it is safe to assume that we are always using bash. We are always using bash. When we display the new line character, we open market with the control character and like this. As you can see, in the echo command, the line feed character is displayed in this way to display the string hello on the screen as follows. It is itself a control character and can speak of line break function. It technically corresponds to a character called line feed in Linux. If you look at the ASCII code table, the line feed character is displayed as 10 in decimal and OXOA in hexadecimal. The word line feed has the meaning of changing lines. In addition, the letter carriage return also has meaningful meaning, but it means that it sends the cursor to the home position. This term originates from very old typewriter and can be called the control character. When moving the character input position to the prompt, always to the next input position after line change. Operation is required on the typewriter, corresponding to an operation called carriage return. This character is decimal number in ASCII code. R is 13, and in hexadecimal is represented as OX or D. In Linux, line breaks are handled by this single letter, called LF, as the line break character. In MS Windows series operating systems, LF and CR, called carriage return, are always used for line breaks. It will always be the necessary character to mark it as a new line character. To summarize, in Linux, for line breaks, one LF character is treated as a line break. In MS Windows series, LF and CR are always required as two characters for line breaks. It will be the main word at this time. The file you see now is a file created in the Linux operating system, and the inside of the file can be printed as hexadecimal value. For line breaks or hexadecimal value called OXOA corresponding to LF is shown at the end. On the other hand, it contains the same hello word, but the line break handling is different from that in Linux. In the case of the following file created in Windows Notepad, you can find differences from the Linux file by looking at the hexadecimal output. It will be whether carriage return is added or not. In Linux, it is possible to process the line feed as one character for line breaks. On Windows, we can see that the line feed character and the carriage return character are handling line breaks with two characters. Because of subtle differences, line breaks are handled between scripts running in shell or documents used in Linux and Windows. Because of these different differences in the script, avoid editors, including Notepad on Windows as much as possible to write scripts. I would recommend the official Linux editor BI or equivalent Linux compatible Linux editor. Let's take a look at the various ways to run the script file. Let's take an example of a script file called Hello World, which is a script file that has already been created. First, as basic method of executing Hello World, which is script file after writing the script file, the execution attribute is assigned with the command called chmod. A script file with execution properties can be executed at any time in the form of the following command. The second way is to run the script file by writing down the name of the program called bash and the name of the script file you want to run. The third way is to run it using a command called source, but you can also run the script file this way. Lastly, as a way to run the script file, you can run the script file by writing a period and a space followed by the script file name. So far, you have been 4 ways to run a script file, and the subtle differences between these methods will be explained in later tutorials. And also check out space characters are tab character, line feed character, vertical tab, form feed character, carriage return character, and space character. This is all white space in English. Instead, spaces are used to determine the beginning and end of words. And entering a command, the first letter is a command name. Any word added becomes an argument to the command. The expansion is marked with the $, and this $. It is often used when referring to variables, but this $. It is used for 3 major purposes: parameter expansion, command substitution, and arithmetic expansion. In the main training content, you will learn about the characteristics of the following individual types of expansions. Double quotes in English, it is called the double quote, and the text in it quoted in double quotes is protected from word separation or argument separation, including space characters. All characters used within double quotes are treated as literal characters, but some characters are meta characters, and their function as special characters survives. The characters with the first backslash, the second $, and the third backtick character. Now it's important to remember that except for 3 characters, all characters including special characters used in double quotation marks are interpreted as literal characters. In the case of the same quotation, marks both single quotation marks, they are called single quotes, and they are also called strong quotes by nicknames. It implicitly indicates that something is powerful, but all characters, including special characters, are interpreted as meta characters in single quotation marks. It has the characteristic that it is interpreted only as literal characters, or characters used in single quotation marks. It is important to remember that it is interpreted as normal character. This backslash character, commonly known as an escape character, prevents characters immediately following the backslash character from being interpreted as special characters. The backslash escape character can be used as a meta character even within double quotation marks. This backslash character is a literal character when used within single quotes and acts as literal character as a backslash character. The hash letter or sharp letter used in the comment notation. Everything from the used line position to the end of the last line is treated as a comment, that is, on the line used by the hash character. This means that any character used after this hash character is treated as command. The meaning of the word command also includes that it is not processed by the shell, so we can understand the meaning of the command correctly. This bracket, called the square bracket, it is used to determine whether the expression in the brackets used is true or false. In other words, it is used in the evaluation of conditional expressions, and this special character has characteristics that are usually used in conditional statements, including if statements. Known as an exclamation mark, this exclamation mark in shell syntax contains the meaning of negate or negation. When a test result is true, if the exclamation mark sign, which it has negative meaning, is used at the same time, the true result is reversed and the result is true. Conversely, if the evaluation result is false, the symbol is special character that, when used together, results in the opposite true. This special character, which looks like an arrowhead, uses the term angle bracket in English and works as a redirection function to specify the direction in the shell. It is used for changing the direction of the output result when the result of execution of a command is exported as output, and can also be used in input. You see, the vertical line, known as the work operator, is the name pipe in English and is used in shell. This special character has the effect of reassigning the execution result of the command on the left to the input of the command appearing on the line of the pipe symbol based on the position where the special character is used. You can create a single command flow by pressing multiple commands in sequence using the pipe symbol. We can call this command workflow. The powerful feature of Linux is that it creates a single processing flow by listing commands of individual characteristics in order. There is an advantage that can be used as a means to achieve one big purpose. That's when the character pipe is used. These special characters, so-called semicolon, are used to separate different commands when individual commands are written on the same line. Functions as so-called command separator, named in English as brace or curly brace. Special curly brace characters are used in the shell for the purpose called inline groups. Commands used in curly brackets are treated like a single command, can be made into command blocks. A special character called parenthesis in English is similar to an inline group, but in nature. The difference is that if commands are listed in parentheses, they form a subshell and are executed in a processed state. Commands and variables used in parentheses are treated as sandbox. It has the property that it does not affect commands outside of parentheses. When two parentheses are overlapped, they are used as special function arithmetic operation. Commands expressed as calculations in double parentheses are mathematical operators used in so-called calculations, including general arithmetic operations. These nested parentheses can also be used in text. Therefore, it is a form that can be seen a lot in conditional statements, including if statements. If you use a $sign together in nested parentheses for arithmetic operations, this is the same arithmetic operation, but the arithmetic result. It is distinct from conventional arithmetic operations in that it is actually printed and expressed. For supplementary explanation, if only parentheses are overlapped, so-called calculations are performed. The difference is that when a $sign is written in the nested parentheses, the calculation result is printed out. Usually referred to as tilde symbol, this symbol is called the tilde in English and represents the user's home directory. So, if a directory path name starts with a tilde, it is replaced with the actual user's home directory path name by extension and used. shows how to create a variable called animal and initialize that variable to a string called tiger. You can see an incorrect example of initializing a variable. When initializing a variable, there must not be a space character on the left and the right of the assignment operator. Let's look at another example. Again, the variable will not be initialized normally because there is space character to the right of the equal sign. Here, there is a caveat when initializing the animal variable, which is called the shell variable, but the caveat is that there must not be space character on the left and the right of the equal sign in the assignment operator. You can check the example of a correct variable initialization again as follows. This is an example of initializing a variable called color to a string called white. The initialized variable can be used in the following way. Unlike initializing a variable, when referencing a variable, the variable must have $sign on the left. Initialize the audiobook, named The Old Man and Sea, by creating a variable called book. To delete the file, you can enter. But the file deletion doesn't work as we would expect, despite having the file. The reason is a problem with the method used to delete the file. You must put quotation marks around the variable. Even if the variable book already contains spaces, don't forget to use quotation marks when using the variable. You can confirm that the file has been deleted correctly by entering the following. Let's see other examples. When you want to initialize two or more variables, you can separate the commands with a semicolon as follows. Each variable is initialized with animal as tiger and color as red. Here is an example of using initialized variables. When it comes to using the variable, it is set to be used with a $sign. Now, the intention of adding s to the end of the variable name as follows would have been to make the singular tiger the tigers and the singular red the reds plural. But you can see that it doesn't work the way we wanted to control it to our intention. Let's try to fix this. When expanding a variable name, you need curly braces like this. The reason is, as you can see in the wrong example, it is not possible to check from where to where the variable name is. So we need to tell the start and end of the variable name. Then we use curly braces to handle it. You can see that the plural was handled as desired. The previous example also worked as intended, but a better way is to make it clear with quotation marks like this. Write the following script file. The $0 used in the script file is special parameter. Also, to understand this script, you need to understand backquotes. A backquote is also called backtick, and the next command quoted as backtick is executed first. The execution result is not discarded, and the next variable input is entered. $0 is path name of the script file we are currently writing, and only the directory name part of the path name is extracted and stored in a variable called directory. Check the contents through the execution result. Save and exit. Then give execution attribute. If you run it, you can see that the current path is displayed on the screen. Running this in a different way seems to make it easier to understand the features of this shell script. I will change the execution method and enter the full path to run it. When executed, you can see that the path name of the current script file has been extracted. Let's write another script file. You can see the special variables $1 and $2 used in the script file currently being created. $1 is a way to receive the arguments passed to the script file to be executed in the future, and $1 is used as the first argument. The second argument is taken as $2, and all past arguments can also be taken as $**. Let's run the written script. Execution property is assigned and execution is performed. According to the usage of this script, a parameter must be passed. So let's enter the arguments as follows. When executed, the argument James is passed to the script as $1. Email addresses are delivered as $2, and each of the arguments can be delivered with the representative $* symbol. All the expressions you've seen now are called special parameters. In addition to the ones you saw in the example, there are various special parameters as follows. In the example, $0 represents the name or path of the script. $1 represents the first argument passed as a positional parameter. Subsequent arguments are serial numbers, $1 and then $2, and so on. After the $9th argument, arguments can be passed in this way, $10, $11. If you add an asterisk to the $, it is used to indicate all arguments passed as transfer factors. A special parameter similar to $@ is called $@ according to the English expression. $shop can be used where $shop means the number of positional parameters. Let's open the script file that has already been created. It will be necessary to know whether or not the arguments passed in the script file are passed. You can add that content like this. If you enter this exception handling code into the script to determine whether an argument has been passed, handles the user's action after passing of arguments. A string of no arguments supplied for conveying some kind of information will be displayed. I will test it. You can see that the following message is displayed only if the argument was not entered by the user. The special parameter character is used as a function to expand to the exact code of the most recently completed foreground command. Putting into $signs expand to the current shell's PID. Underscore. The underscore with $sign expands to the last argument of the last command executed. Underscore. The underscore with the $sign expands to the last argument of the last command executed. Let's look at the topic called the environment variables. Variable called the UID, which is reserved in advance, is called the environment variable. Then we are seeing an example of using the built-in environment variable. The environment variable called UID represents the ID of the user currently logged in and used. You can see that the default user has a current UID of 1000. Let's write a script file. EUID, which is also an environment variable, means effective user ID, and according to the English expression, it is called effective user ID. Normal users can also have root privileges. In Ubuntu Linux, you can use sudo to run commands with root user privileges. After writing the following script file, let's run this script file. Save it and give it execution properties. Try running the euid.sh script file as a normal user. You will see a message on the screen telling you to run as root user. Checking the effective user ID to see if you are root user. Run this script file with the root privileges called sudo. If you run it after entering the password, you can see that the script file is executed normally. This is a good example by letting you determine whether the script file execution subject has root authority. Let's look at another example. There is an environment variable called random, and I want to print this environment variable to the screen. You can see that the random value changes with each run. These environment variables can be checked with a command called env. Let's start shell programming training. Variables can be declared in a variety of ways with the declare command. The example you're looking at now shows how to create an array called alarm. Arrays can be used for variables written later by reducing the A option as option to the declare command. An array is basically indicated by parentheses to indicate that it is array. Write down the elements of array and enter parentheses on the left and right to indicate that it is an array. Let's check if the input array is valid. Declare can also be used to declare variables for other uses, as you can see in the examples below. If you write the I option, the variable 78 called enum can be used as an integer variable. Integer variables declared with the declare enable these operations, which are not possible in the usual way. Let's look at the characteristics of integer variables using declare by performing a similar operation with variable declaration in a general declaration method. Let's initialize a variable called enum in a similar way. Probably not working as we expected. In the shell, just because a number is assigned to a variable, the number 78 stored in this variable is not recognized as a number. It is recognized as the letter 7 and the letter 8. So it is not surprising that this result came out. However, according to the declare integer variable declaration method, it is specified that the declared variable is an integer type, and this phenomenon becomes possible. Let's see another use of declare. You can also make the variable read-only. This declared variable cannot be reinitialized to another value. If you write as an option to the declare command, the variables you write afterwards have the same effect as if you write export. After that, the child process can access currently declared XPath variable. In a similar way, the following could be: initialize the following variable as a string. This is method of outputting the number of characters in a string in a desired variable. You can print the string from the desired position in the string. Since we gave the starting value, all you can see all the strings are printed. I adjusted the offset value and printed the second letter. You can see that the second character of the string stored in the test string variable is printed from the fourth letter. You can enter the beginning of the string and the number of characters. From the fourth letter, you can see that 3 letters including total spaces are printed. You can truncate strings starting with capital T. The ending letter is the letter ending in IS. Please check what part of the current test string has been cut. You can see that the text string stored in test string has been cut to the currently selected part with the mouse. Similar but slightly different coding method is that the hash character was written 2 times. The largest set of characters starting with the uppercase T and ending with IS is removed. So if you run this, you will get rid of words that start with capital T and no longer appear in IS. As expected, I will check to see if the result is as expected. It does not remove the first part of the string, but a method that removes the matched part of the last part. Words starting with the lowercase is and ending with not are removed. Expected is not this part, is expected to be removed. I also confirm that it is working like this as expected. If you write 2% characters in a row, a large range will be matched and removed. Words that no longer appear in IS will be matched and removed. I also confirm that it works as expected. This is method of removing or pattern matching parts that match the word that. When you run it, you can see that all words matching that word are removed. Find the word and replace it with the word this, just to make sure that only one word in which the match occurred is replaced. Find the word that and replace it with the word this, regardless of upper or lowercase. Again, make sure that only one word has changed. In this case, 2 slashes are used in succession. Find all the words and replace them with the word you want. Finding and replacing the desired word is the same as the previous method, but it has the characteristics of finding and collecting only the first matching word. A similar example will be an example of changing only one by pattern matching at the end of the string in the variable. You can see that the word not has been replaced by only one of the last criteria. As you can see in the example so far, variables in which strings are stored can be modified to desired pattern by removing desired word or part of the string by the following operation called the substring. In shell scripts, the following manipulations of strings occur frequently, and the methods we learn now will be utilized a lot for this manipulation. Let's go to the top level directory of Linux. Use the echo command to take a list of files in the current path. Only print directory names with 3 letters. Print a list of 4-letter files. Print a list of files starting with the letter B. As you can see, the question mark special character corresponding to one character, so when printing the file list using the echo command, it is possible to output the file list according to the number of characters. We call this the globe pattern. The globe pattern also exists in the following form. All directory or file names matching letters A through D will be printed. You can also mark boundaries. You can achieve the same result by simply marking the beginning and end of A through D with a hyphen. Try entering the following command. The string hello world will be displayed. The command tr means translation from each name. You can input a file and output the contents of the file in a new text format. The character format to be converted can be defined by user and. According to the current example, the lowercase letter A is the uppercase letter G, and the lowercase letter B is the uppercase letter A. With the same trick, the letters A to G are translated into a new letter pattern. In the current example, here string is new instead of file. This here string will be converted in a separate chapter in the future curriculum. If you want to see here string in advance, check the link at the top of the video. According to the example now, hello string is a string, but according to the principle of a here string, it is actually passed as a file to the command tr. tr receives file as an input and converts it to new character pattern when matching corresponding to the character occurs. After running it, we will see the result and talk again. The capital letter H did not have a separate pattern matching, so you can see that it came out without filtering. The second letter E corresponds to the 5th letter, but it is also changed to the 5th letter D, corresponding to the new pattern, and you can see that it is printed on the screen. If you match the letters one by one, you can expect the translation to come out as we expected. tr can be used in other ways besides the following examples. Let's see the examples going on. Lowercase input is translated to uppercase output by the following syntax, called the spacious representation method as follows. So the expected result is that the current mixed case file input called camel case will be converted to all uppercase. Space characters will be converted to tab characters. It also works as expected. White space characters that are repeated multiple times are converted to a single character by the squeeze option. All white space characters are removed with the D option. If the C option and D option are written side by side, the corresponding white space character is not removed, but the opposite result is that only white space characters are displayed on the screen. There seems to be no output in the execution result, but in reality, a lot of white space characters contained in the hello world string we wanted would have been printed on the screen. By using the tr command we have seen so far, we can convert the string we want or convert the file to the new string pattern we want. It is also possible to remove certain characters. We could see with our own eyes that it is also possible to change a repeated string into a single character. The fruits.txt file containing the fruit name is printed on the screen. A list of 5 fruits, including grapes, is shown on the screen. Using the command called cut, you can extract only the desired part of the string. Currently, the target of string processing is a file called fruits.txt, and as you can see in the cut, the file is being received as input. Cut takes the file as input and processes it. You can see that the second letter is printed on the screen in fruits.txt. You can select the section included in the text string of the file and print it on the screen. You have seen how to print between the first letter and the third letter on the screen. This is how to print from the third letter to the last letter. In a similar way, you can see that the first letter to the fifth letter are printed. You are looking at it as a way to print out the first field of the environment file called password. The environment file password file is originally composed of fields with colons as a separator. In the example cut command you saw earlier, you saw how to extract only the first field of the password file. The option to extract only the first field was used, specifying a colon as the delimiter field separator. You can also select 2 or more fields of your choice. The command to extract the first and sixth fields is being used. We're making sure it's working. I made the example sentence by typing quite a bit, but you can see that IP address appears. When you enter the ifconfig command, there are outputs on the screen. Only the IP address is extracted from the contents. As you can see in various examples, the cut command is used as such a function to extract the necessary part of the string. You've seen that you can use the cut command in shell script to handle various strings. The list of files in a directory called images is as follows. If we wanted to see only files with JPG extension and files with BMP extension, we could enter. Let's assume that we want to see the rest of files except JPG and BMP. If so, we can think of an expanding globe. Since the expansion globe is not normally activated, you must activate it first before using it. You can activate the expanded globe with the following command. After the extended globe is available, you can type the following command to list only files with extension JPG, BMP. As you can see, only the file list, not JPG, BMP, is displayed on the screen. The exclamation mark used here means the list of files except for the list of files listed on the right. In other words, it has the meaning of not. When listing more than one content, use the pipe symbol as follows. However, there is a caveat that space characters should not be used within parentheses. This is the part that you need to pay attention to. In addition to the exclamation mark, there is also extended globe special character called @ This allows you to display any JPG, BMP file. As used here, it can be seen that now the knuckle has the meaning of OR. JPG extension, BMP extension, you can use these as symbols right away when you print anything on the screen. In addition to this, there is a list of meta characters such as +sign, question mark, asterisk, symbol, and exclamation mark for extended globe special characters. You can use it according to your needs. When writing a script, you accidentally make a lot of grammatical errors. It can be said that it is quite painful for us to collect every time an error occurs. Introducing ShellCheck.net, a popular website for static analysis of shell scripts. On the website, we can copy and paste the contents of shell script and check the script for errors. It's not perfect, but I think you can catch a large number of bug errors using static website analysis tools. Anyone thinks that it would be nice to have the content printed on the screen in color. You can print colored text in the following ways. We can specify the style of the font, the color of the font, and background color of the font so that the desired color comes out. How to use color text. First, enter the escape character and \. Please decide your style. You can define and use various styles such as bold, underlined, and italic. Decide on the color of the font. Please decide the background color of the font. You can see the colored text corresponding to the color and style you choose. The list of available colors can be used when creating color text by referring to the color table for each of the foreground and background colors. Style can also be defined. Bold, underlined, flickering letters, background and foreground colors can be reversed, and these can be specified as styles. How about applying the color text function to something like a prompt? Change your terminal prompt color. Regular expressions are special strings designed to search or replace strings. In Linux, grep seed, and awk commands use regular expressions. Using regular expressions, you can manipulate strings in a more convenient way in a variety of ways. There are websites designed to practice to run regular expressions. We are going to use these websites to run regular expressions. This is the redirections.com homepage, a website that can be built using regular expressions. Regular expressions have slightly different syntax depending on the JavaScript per script. Since the website does not support the exact test method for the Linux shell, please set it to the most similar per script mode and practice. Here is an example of a string. I can't do regular expressions well from the beginning, so I'll introduce the grammar one by one. Try typing A in the input field. You can see that the letter A and all the matching parts are marked. Likewise, type in square brackets and add the letter B to the letter A. Please close the brackets. You can see that everything that matches the letter A and the letter B is marked. We keep typing the letters of the alphabet we know. I think you've guessed roughly here. All the letters that match the letters displayed in the brackets are selected. Rather than typing all 26 letters here, you can simplify the input as follows. You can include uppercase letters. You can also include numbers. On the current screen, all numbers including upper and lowercase letters are selected. If you want to hold the part that does not match with this letter that's currently visible, put a square bracket immediately after the bracket. The meaning of this bracket has no meaning of not. So, you can see that all letters except upper and lowercase letters are selected. If you see now, the paragraph is now showing. Then, let's take a look at the grammar of selecting only one word at the beginning. As a meta character, in regular expressions, dots represent all letters. You can give the number of repetitions, but if you put a plus sign in the meta character, you can see the repetition of certain characters. And if you enter space character, it means a certain character and a space character, that is, a word that ends with a space character. If you close brackets, open brackets, and include a space character, you can see that a specific pattern has been selected as follows. You can see that a specific pattern, regex R, has been selected by entering an angle bracket at the beginning. If you delete this bracket you entered at the beginning, it will go back to the original. The following regular expression can be represented simply as meta characters. Entering a backslash and lowercase w selects both upper and lowercase letters and numbers. Use a period to mark all characters. This meta character represents every characters. Therefore, if you look closely at the moment, you can see that matching occurs at every single letter. If you want to select multiple characters by giving the number of repetitions, use the meta character plus sign to indicate the repetition. This way, you can use it as a function to indicate the repetition of the corresponding letter. You may want to select a space, but in the case you use backslash and s, you can see immediately that all white space characters are selected. Conversely, if you want to select a word that is not space character, enter capital letter S. All non-white space characters will be selected. In similar way, if you enter lowercase w, it indicates upper and lowercase letters. If you change it to uppercase letters, or letters except uppercase and lowercase letters are displayed. A similar principle can be applied to numbers. As an example, let's enter a few numbers. If you enter a lowercase d, only numbers are selected. And if you enter an uppercase D, all contents other than numbers are selected immediately. You may want to choose a word. In the case, please enter plus sign in the period representing all letters and enter the word boundary. This way, you can only select words. If you observe, you can see that words and words are separated. Let's check the meta characters that represent the repetition of certain characters. If we type in a lowercase n and the meta character plus, which stands for repetition of one or more letters, you will find that it's found as a repeatable pattern of lowercase n. The address of the website is coming out. Let's say that only domain addresses, including HTTPS, are pattern matched among the following contents. Then you can type. Let's look at the website address. When I say that website address I want to capture is the following website address, if I enter a regular expression to pattern matching the content, it will look like. Just note that this slash character needs to be escaped specially. After being escaped, you have confirmed that pattern matching has been done well. Let's assume that we want to capture everything that starts with HTTPS, not just HTTP, that we want to do pattern matching. Then, we can erase all the contents of the website as follows. Enter period, a meta character representing everything, and then enter the number of repetitions. However, as we intended, the reason why all website content went out without being selected is because of the difference between one S and no. In this case, enter S, and immediately after this letter, write the quotation mark character, which is also meta character. This way, due to the nature of this meta character, pattern matching with or without the previous character can be achieved. So, for this reason, both patterns were chosen. Now, two lines of domains called website are selected, but let's say that another website also chooses a domain. Then we can treat this in a different way. Enter website.com, and period representing all characters can be used as literal characters. So escape them to make it clear what they called literal characters. If any character is escaped, it loses its function as a special character or a meta character and is treated as literal character. In the previous case, the reason for escaping the slash was to treat the slash as a literal character, not a meta character. Now, the bottom line, part of the pattern matching on this website that we currently select is unselected. In this case, we can open parentheses and create groups. Enter www, complete with the period, and close parentheses. Then enter question mark symbol to select all of these groups with or without. Then this question mark meta character unpacks this beta group, selecting all of the contents of this group with or without. So both lines are selected. The same principle can be applied to HTTPS, but each all tied together. If we put a question mark here as well, you can see that all website addresses that do not contain HTTP are now selected. Let's take the following website document, CSS document, as an example. This color which means a color that starts with hashed letter, allows us to recognize it with the following pattern. First, it identifies the characteristics of the pattern and then reflects it as it is. Our colors are displayed as hexa value. Case should be irrelevant and numbers include. Then I write down the pattern expression. Let's start with hash letter, and numbers from 0 to 9 will be used. And lowercase letters A to F, uppercase letters A to F are letters expressed in hexadecimal. Write down repetition of this. Then you can immediately see that the color pattern starting with the hash letter corresponding to the color value has been selected with the regular expression. Let's try color pattern matching according to the CSS method, starting with another color expression RGB. 3 letters called RGB are used, each of which can be capitalized. So all these letters are tied together. Then you can see that all the patterns called RGB matched and were selected. Parentheses are meta characters, so they must be escaped. There is a number, and the number can be from 0 to 9. This number is repeated 3 times, but if you look at the selected content, you can see that only 1 digit has been selected. In this case, you can use curly braces, another expression for repetition. All letters from 1 letter to 3 letters are subject to matching. From 1 letter to 3 letters, or letters from 1 letter to 3 letters are matched. If you look at the selected ones, you can see that we are getting into pattern matching now. The reason is because there are and no space. So we can handle this too. You can try to do this using the meta characters / character, in which case it may be wiser to use a space character. And numbers have to take into account or exceptional circumstances. As you can see now, there are some things with 6 letters, so you have to change them all in this way. You can see that all of the RGB color patterns and CSS patterns have been successfully selected. If you take into account that the % sign is used, we would very easily just add the % sign here. You can also make a decimal point, but in the case, just add the period as a regular character here. To use RGBA in addition to RGB, enter A and enter a question mark. And if you want to process up to the 4th element separated by commas, you have to add more at the end. Open the parenthesis first, then enter it, and enter question mark to finish. Then you can see that all 4 elements are selected. We can try more, but we will finish defining the CSS color pattern matching, pattern expression. Let's show the pattern matching of the IP address. The IP address is characterized by only numbers, and the number does not exceed 3 digits. I can just move it in a pattern way. Repetition occurs from 0 to 9, and the repetition uses at least 1 to 3 letters. It is characterized by period as a literal character and you just need to add this pattern expression a few more times. 1, 2, 3. The last part should be erased. It was a pattern expression definition for selecting an IP address. Consider a situation where there are 2 or more places where the word welcome is now visible. If we type this to search for the word welcome, all words will be selected. Suppose I want to find only the word that the word welcome is looking for is at the top of the line. At the time, if we enter angle bracket meta character in front of the line, the word welcome must be at the beginning of the line to be selected, because of this angle bracket character which symbolizes the beginning. Otherwise, the word welcome will be excluded from pattern matching. If even a single space character is entered here, it is also excluded from pattern matching because it cannot be considered as a word at the first letter of the line. Let's add another word for testing at the end of the line. If the word welcome is not pattern matched at the beginning of the line, and you want to do pattern matching at the end, enter meta character $ at the end of the line. Then the word welcome will succeed in pattern matching only the word at the very end of the line. Imagine that you choose from the first letter of the line to the word welcome to the first word where the word welcome appears. If you select welcome after entering the meta character meaning all letters, period, and number of repetitions, pattern matching is performed until the word welcome no longer appears. This is called greedy mode. It is the same meaning as greedy quantifier. Right now, this is the meta character plus character. If we say that we will do pattern matching only the first occurrence of this word, welcome. If you look at the result of a pattern matching, the pattern ending with the word \, you can see that the first line was selected, and the second line was pattern matching until the very end. Then, if we say that we want to stop pattern matching at the first welcome, we can display it by entering a question mark in the quantifier as follows. If you look closely, you will find the word \. And the second match begins. Matching will take place until the word welcome is first found. The second pattern matching took place because the welcome is first found right here. We call this range quantifier. This way of using a question mark in the meta character plus sign for the number of repetitions. In English, we use the word range to denote it. In summary, the greedy quantifier refers to when there is no question mark, but the pattern is matched to the largest extent. However, in the case of range quantifier range, we must remember that the pattern matching calls pattern matching in the narrowest range. Until now, I believe that you will have good grasp of meta character expression method that is often used in regular expressions and what characteristics are called regular expressions. We will see examples of how regular expressions are used in various commands in future Linux shell programming. For comparison, you can use regular expression pattern expression. Let's look at the following. I'm querying the user and press Y. Your selection should have been saved in the reply variable. The evaluation is based on the selected result stored in the reply, and a regular expression is used at this time. As you can see, you can write equal sign and tilde sign side by side and enter the pattern expression on both sides of the regular expression. Notice that we use the exclamation mark corresponding to negate to make the whole result true when negative was found. It can be either an uppercase Y or a lowercase y, and the letter defines the start and end with end brackets, and dollar signs indicate the start and end on the left and right. There is no response because Y is selected, but if the user pressed N instead of Y, the exact one command would have been executed. Let's look at the second example. Create a pattern expression and check what is called the environment variable length using pattern matching. You can see that the locale information stored in the environment variable length was extracted by two letters and printed on the screen. When pattern matching is performed, only when it is successful, it is stored in the environment variable partially match array in the order in which the matching occurred. The first two matched letters are stored in the first array partially match and the second match result is stored in the second element partially match in the second array. So you can see the following result. When comparing using regular expression patterns, it is a rule not to use quotation marks. All of quotation marks can lead to unwanted result, so caution is needed. It was shown that pattern matching comparison can be performed using regular expressions. Write a script that checks if the value entered by a user is number or not. There is a file called president.txt listing the names of the presidents as follows. Let's use this file to run the grep command. Grep is a string search command used since the traditional Unix days. This command is widely used to search for a desired pattern in a file or directory. This grep command supports regular expressions, so it is useful to write down the regular expression pattern you want and use it to find the pattern. Let's do a pattern matching in the president.txt file that starts with the word George and ends with Washington. Only one string is found. Let's continue to see examples of using the grep command. Option to check how many times the word George appears. You saw an example of using the C option, which means counter. It is an option O that prints only the part where the desired pattern matching occurs. You can see that only the part where pattern matching occurred. You can see that everything from the word George to the last string is printed well. Now, let's look at the next example. The feature is that byte offset is up together. I'll keep watching. If any one of the words Donald and Obama is found, it will be the pattern matching method to print the contents. You can see that it was printed well. The peculiar thing is that the pipe symbol means or here, right? Notice that it is escaped with the backslash just before the pipe symbol used in the meaning of OR. Because of this inconvenience, there is a command called egrep. This command performs OR operation, normally without escaping before the pipe symbol. Notice that the grep command is preceded by the letter E. This example conveys a very unusual situation to us. At first glance, I expected it to search for all words that contain the word George, which consists of one or two numbers, and I typed it like this. But in reality, I can't find anything. This can be solved in the following way, but if you use the POSIX expression method, you can see that the search works well. So enjoy using POSIX pattern expressions in grep commands. It would be nice if we remember that there are times when it doesn't work. Let's look at the next example. The uppercase, lowercase, and an option, which means to search regardless of type, is an option to search regardless of type and is very popular option. Find the word Richard regardless of case and pipe it to the next output. The following command grab only trace results that do not contain the word Nixon. Therefore, you will not be able to see lines containing the word Nixon in the output that has been printed. Option B means not, where no corresponding pattern match is found. The following example shows how this option can be used. It's a pattern type that finds blank lines. I used the pattern expression to find blank lines, and the option C to show how many were found. This pattern can be used to confirm that there are no blank lines in this document. I wrote a pattern expression that means to find all that apply to the 1980s. Also, only the last string pattern starting with 198 was found in the last string and showed well. What is noteworthy here is the last dollar sign. This is an example sentence that emphasizes that pattern matching occurs at the end through a dollar sign. Before and after, which finds the desired pattern expression, and as a line before and after the pattern, it's a function that shows one more line on the screen. The search results are now cut, but you can see that the line in front also appeared. After that, the pattern matched part is line 40, and you can see that the next line is also printed. It's a useful option to see the content before and after the search target where the pattern matching took place. The first letter of the line is not a number, and it must be the first letter. Now the search is done in a special pattern. Only strings starting with the alphabet that did not start with number were found in the file and displayed on the screen. After printing using the ifconfig command that shows network information, searching for INET address again from the output result, extracting the second field through cut, and targeting the second field extracted by this field separate colon. Only the first argument is just such an order to find and extract it. This is a command that we saw earlier, and through this command, you can check the characteristics of the grep command or the pipe command. There is also a command of the form frwrap, which is designed for general searches, not regular expressions. Therefore, regular expression meta characters that are less in the pattern expression are no longer interpreted as meta characters, and all are interpreted as literal characters. So no escaping is needed, because all characters are interpreted as literal characters anyway. frwrap is a useful command when used for general search and not regular expressions. The grep command is first grep, the second grep, and the third fgrep. There are 3 types of grep commands. We can use it selectively as needed. The grep command is very useful command in that we can easily search and find the word we want in a file or directory, and it is very useful in Linux. Let's create a new document with only numbers. A file called nums has been created with only numbers from 1 to 100. You can check the output on the screen by selecting only the desired part from line 15 to line 18 of the file contents. The following file is used to see the use case of the sed command. In the president.txt file, change the word George to the word Tom, and let's check the changed word. As you can see, the word George has all been changed to the word Tom. If we use redirect and save the output to a file named president.modified.txt, we will get a modified president.modified.txt file with the word George changed to the word Tom. You can see that what was written in the word George has been changed to Tom. You can also see that the word George has been changed to Tom. Such traces can be found in several places. The number 1981 in president.txt will change to 2981. You can see that the word that was originally in 1981 has been changed to 2981. You can easily change the string in the file to a new string you want by using the sed command as follows. Also change 1981 to 2981. It is noteworthy that the fact that the words that appear more than once per line have been changed is the difference from the previous method of execution. From the result of the previous line, you can see that the number 1980 has changed only once. You can change and replace all words that occur more than once by adding G at the end of the sed option. Regular expression is also possible, and you can check that only the strings corresponding to the desired pattern expression are displayed on the screen by this method. The SED command enables regular expression pattern matching substitutions like this. If you run it, you can see that one last letter has been deleted. This is also the result of regular expression pattern matching. Some more complex commands are listed. A variable called sp is a space character, and a variable called tab is tab character. SED modifies the contents of space characters and tab characters into pattern matching according to the regular expression pattern as follows. If the pattern is repeated between 2 to 5 letters of a space character and tab character, you can check that all characters are removed after matching the corresponding character and output on the screen. As a result of learning, a file called ms.txt should have been created. When outputting the actual file contents by xdump, I created a file containing a line feed and a carriage return, which are line feed characters respectively at the end of the last string of the MS-DOS Microsoft Windows compatible file format. We will try to convert this MS-DOS compatible file to Linux format using the SED command on the following files. You can do this by using the SED command you are currently running. I removed the text OXOD from the end of the MS-DOS string shown on the screen using the SED command. This command deletes the last character of a regular expression pattern matching. Pattern matching and erase the corresponding letters. Let's check if the last carriage return character has actually been removed. You can see that the last character OXOD character return has been successfully cleared. Among the fields separated by columns, you can use pattern matching to find the pattern of the part you want, and pick out only the part you want. Then, we will see the execution result and continue the explanation. Pattern matching targets files under the etc. directory called password, and you can see that only the first field is extracted. Basically, write down the pattern expression you want to find. If you repeat a letter that does not start with a colon and think of it upside down, you can judge that it is until the letter called colon appears. So it'll be the pattern expression that defines the first field. You can create a group by enclosing it in parentheses and replace that group with one directory. So I extracted only the parts I wanted. In other words, you have seen that you can easily extract a substring, string parts using the SED command. The current command is an example using a syntax called herestring. About herestring, we will run it on a separate chapter. If you want to see herestring first, Please refer to here string at the top of the video. Here string syntax is if you write 3 angle brackets side by side, calling it here string. According to this here string syntax, the string after 3 angle brackets is passed to the input file with the corresponding command as indicated by the arrow. Therefore, the sed command does not accept a string. It is delivered in the form of a file. The sed command receives the following file and receives the regular expression, pattern expression, word boundary. A character separated by white characters such as space character or type character followed by a single character. Therefore, the letter is replaced with a new pattern expression. Let's run it. You can see that the result entered by the sed command has been changed to uppercase. In Hello World, you can see that the first letter of the word boundary has been changed to uppercase. You can see that for the inline group, only the selected part was capitalized. Also, you can see that the second letter corresponding to the word boundary, W, has also been changed to uppercase. It was changed to uppercase according to pattern matching. As you can see, we can see the sed command to see that we have similar effect without using a separate command called tr. Another similar example is the case of converting character types. Here you can see that the desired character pattern has been changed to a lowercase. You saw that the uppercase letters of the letters at the word boundary were changed to lowercase. Let's try entering the following command. It's called brace expansion. String contents enclosed in curly braces are all separated by commas. This string is concatenated one by one with the words outside the curly brackets. So, if you run it, you can see that the number of files named no name has been created as many times as you specified. With curly brace expansion, you can do interesting things. Let's say we are going to create 9 directories named dir. Then we can easily do it using brace expansion. Brace expansion can mark each string using a comma. You can also specify the area by specifying only the beginning and end of the letters in numbers or alphabets. To specify the area, enter 2 periods to mark them. This is also possible with curly brace expansion. When run, a directory called new project. You can see that it is made in hierarchical structure. This also. It can be described as an example implementation using brace extension. The command called eval recognizes and executes the string listed after eval command as a single command. The reason the eval command is used here is that if this command is omitted, there is a situation where this command cannot be executed normally. It doesn't actually run as it is when a variable is used in brace expansion. That is, because variable expansion doesn't work in curly brace expansion. To solve this bad problem, we actually enable variable expansion through eval. In this brace extension, grammar that actually defines the start and end values, the part where the original constant value number will be used. When we absolutely want to use a variable called length as a character variable in curly brace expansion, we have to consider the command called eval. First, I will explain the effect of the eval command after execution. First, I'll see the results and talk about it. If you look here, you can see that the variable code line of the printf command was declared and the hyphen string was repeated 40 times and saved in the line variable as formatted output. Actually, the results are also coming out as expected. Then I explain the effect of the eval command. If you extract and run only the substring from which the eval command has been removed, in fact, we can see that it doesn't work as expected. In other words, no variable expansion has occurred. So, we can see that using the eval command actually caused the variable expansion. Brace expansion is also useful in the following situation. Suppose you want to create a backup file of file called president.txt. If you run it like this, you can see that a copy of president.txt was actually created. President.txt has been concatenated once. Brace expansion has taken place, and there is virtually nothing to the left of the comma. The concatenation occurred once with a string with nothing. Then, the string to the right of the comma is also combined once. Actually, it has the same effect as entered as follows. Using brace expansion, it is intuitive and actually simple expression. It would be nice to check that the desired string can be expressed. I entered the string C in len, indicating the locale of the environment variable, and I take the current date with date. You can see the current date displayed on the screen. I print the current date in the desired pattern as follows. When printing out today is a few days, we use the method called command substitution. Command substitution is basically a combination of $sign and parentheses. If you enter the desired command in parentheses, the command is executed first. The execution result can be expressed as a string. Therefore, as you can see, the command substitution used inside the string quoted with double quotation marks in the echo command has the effect of being executed first inside the string. There is an expression like this or similar, which is called backtick or backward. You can see the same effect as the command substitution you are starting now. You can use command substitution as needed or backwards as needed. I think the readability is better. Therefore, I personally believe that making the code easier to read is that command substitution is more readable than backwards or backtick. You can see that command substitution is being used in this example as well. The execution result will be stored in variable dir1. Let's proceed. It can be said that the error indication on the screen is natural result. I tried to go to a directory called dir1 and it would have failed as a result because dir1 doesn't exist. If moving to the dir1 fails, and the command on the left fails according to the effect of the following logical operator, the command on the right is executed. Please refer to the link at the top of the video for the corresponding logical operator. On the right side of the logical operator, something called the inline group is used. If the directory is created and the result is true, the logical operator also executes the command on the right. Also, refer to the link at the top of the video for these logical operators, creating a directory, moving to that directory, and actually executing a command called pwd will be the contents of this command. Then, we will check whether it runs normally through output to a variable called dir1. If executed normally, the dir1 path would have been saved in a variable called dir1. Looking at the results of yesterday, we can confirm that pwd was executed normally as we expected. We stored the number 12 in a variable called v1. Let's say we wanted to add v1 and 34 and store it in v2. We can express it like this, and you will see that v2 actually holds the value we expected. The expression used now is called arithmetic expansion. In order to perform arithmetic operations, such as for arithmetic operations and modular operations, write the two parenthesis characters side by side and the required operation, and also the parenthesis closing character. If you write two side by side and close the formula, we call this arithmetic expansion. The operation of adding the variables v1 and v2 and storing them in the variable v3 is expressed. You can also use the following expression method. Given that you made the same calculation, which of the two expressions do you feel is more readable? It would be great if you could not use dollar signs on variables inside arithmetic. Basically, we run that variables should use dollar signs when references occur. However, with the exception of arithmetic expansion, this variable name can be referenced without using a dollar sign. We will be able to use commands that are more concise and intuitive to read if we take full advantage of this point. You can use the increment-decrement operator. In the command you see now, the dollar sign is not used, but the arithmetic expansion without the dollar sign does not print the result of the calculation on the screen. You can also use the complex assignment operator, which is the operator used in the C language. An example of using the if command is shown. Since the command called true always returns true after the command is executed, and the if command will display a message saying true as follows. If so, what about next? You might have expected the word true to appear on the screen. However, in reality, we can predict by looking at the result of execution. So, why did this result come out? We can infer why this result came out by entering the following. The command shown above has the same effect as entered as follows. You probably know that the number O always stands for true and 1 stands for false. Therefore, true is actually a command resulting in O, and the above command would have been interpreted as in the following command. The execution result is false, but the if statement shows what you need to pay attention to. In the shell script, the if statement deals with true and false. Note that the number O is actually judged as false in the if statement. This is something to be aware of in the shell script. In the shell script, it was said that true is symbolized as number, but O as number is not so. So the number O used in the test statement used in the if statement is actually treated as false, and 1 as the number appears as true. The result will come out. Let's predict the result of executing the following command. We have learned that arithmetic expansion using $signs actually prints the execution result to the screen. Therefore, the result of this execution is 0. We have already confirmed it through a case before and have proved it again. The number O is printed on the screen, and it would be tried to run again as command. Therefore, O is not command, so it is not surprising that the following error message appears. Let's say you want to delete a file called myfile. If the file doesn't exist, you will get an error, right? Now let's run it. As expected, an error message appeared on the screen because the file does not exist. An environment special shell variable $! That stores the execution result saying that an error occurred. We are able to confirm that the most recent executed command by the error occurred as follows. If it was normal, the exit status value would probably be O. The command generated an error, and this exit status was saved in a special shell variable. Depending on the result, 1 came out. We'll see you can use this in the following way. Again, the result of execution will end in failure. Therefore, the right inline group will be executed by the logical operator that is executed only in case of logical operator failure. Again, the execution result was as expected, but the notable thing here is that the exit command was used. Exit is the command used to exit the currently logged in shell. When O is used for exit, the shell is terminated with the number O, which means true, meaning the exit code is returned. However, if you use 1, that is, if you use the exit command with a value other than O, because the exit code uses 1, a symbolic number representing failure, it is interpreted to mean that an error occurred when exiting the shell. This command exit can be found in many shell scripts. After executing the shell script, you can use exit 1 to mean the failure exit, and any non-zero number can be used to mean failure. Checks if there is directory called dir in the current directory. But there is no directory called dir in the current directory. Then the execution will end in failure. Here, what is called the logical operator has been used. Two of these characters, called pipes, symbols, and vertical lines, were used in succession. We can use this operator and use this logical operator to write the command on the right and execute it only when the command on the left fails. This command was used to create a directory when it doesn't exist. When I run it, the error message comes out as expected. You can see that a directory called dir was actually created. It was made in time right now. You can check that the file is currently created through the time information. You can see an example like this. The logical operator is also used here, but unlike the logical operator used earlier, this operator only execute the command on the right when the command on the left is successful. You don't need to pay much attention to the error message here. Here, the topic is geared towards logical operators. It was an example of a logical operator, in which the logical operator executes the right command only when the execution result on the left is true. Linux developers know a lot about this tool called make. Even in this make command, this logical operator is used as follows, and now this logical operator can provide a lot of convenience. The compiled result can be installed by the command on the right only when the command called make normally executes the command called compilation. If the command on the left fails, the command on the right will not need to be executed because the compilation failed. That's what we can use easily and conveniently by logical operators in the following shell. If you log in using the console, SSH, or a command like this, you will get an interactive login shell like this. If you log in graphical mode, you don't get a login shell. You get Session Manager or a Window Manager. Starting a shell in an existing session terminal creates an interactive, non-login shell. If you pass a script or command from the shell's command line, the shell is non-interactive, non-login shell. Using the shell command, you can check whether you are currently in the login shell or not. The semicolon used in the example is called the command separator. As the name suggests, the command separator is used to separate commands from commands. If command can also be expressed as As you can see in the example, you can see that the semicolon is replaced by the new line character. Again, the result is the same. We've seen that multiple lines of command can be entered on a single line using command separator semicolon instead of a new line character. If you use the command separator, it is possible to enter it on a single line, so it is more readable, and paradoxically, it may be less readable, but you can think of it as a grammar that can be used conveniently depending on the usage. The string called so is saved in the variable tool, and the result is displayed on the screen. What would be expected if you remove the semicolon? Will the string called hammer appear on the screen? If you actually run it, you can see that the string hammer is not saved in the variable tool. If you initialize the original variable and use it in a later command, this variable will only take effect on this command. But there is a problem here, and the point at which variable expansion occurs. Actually, the reason the result was different from what I expected was that the character string was stored in a variable called hammer. However, the point at which this expansion took place is a problem. Before the string called hammer was entered into a variable, the string called so, which was already expanded and stored in a tool, was applied first. Therefore, the execution result was saved in the tool that was already saved instead of a string called hammer. So is shown on the screen. Then, why did this result come out? This variable called tool only affects command echo, which corresponds to the output on the screen. So, after this command is executed, this variable is also destroyed. Therefore, the scope of this variable is limited only during the execution of this command. A variable called this tool used in echo is displayed on the screen using this variable that was declared previously. Care should be taken when applying this variable to the corresponding command without using command separators. In this example, you can see that logical operators are used a lot. If interpreted and first there are 3, and the directory actually exists, it will be true. The execution result will be true. When the situation indicates success, the content on the right is executed by the logical operator. The contents of the directory will be displayed on the screen. If this is successful, a logical operator with a supposed function is used that is not executed now. If this fails, the mkdir command, which is only executed, will be executed. However, it is expected that this command will not be executed due to the content on the right. If true, the echo dir directory is made string will be displayed. Then, let's check if it works as expected. The execution is the same as the expected result, but it is necessary to revisit the principle in which this sentence is used. The user's intention is that if the directory is found, it is a sentence that says the directory is here. If the directory could not be found, the following command would have been used as statement to execute. This REST statement, dir directory is made, can be thought of as command with dependencies attached to this command starting from mkdir. Largely in the first group and the second group, this sentence is interpretable. Therefore, it is no problem that the execution result on the left side affects the right side, but this statement shouldn't be interpreted as being purely dependent on the mkdir command. If you run it, you can see that the statement dir directory is made, which should not be printed, is also printed. We can try to solve this problem using a method called inline group in this case. Bounding the desired parts. Now this sentence can be interpreted as: if a directory is found, it prints out on the screen that the directory was found. If it is not found, the following statement, which is grouped together, is executed, and the string message indicating that the directory was created after the directory was created will be displayed. Then, please take a look at what has changed through the existing execution result, the collected content, and displayed message. The directory was found, and the message printed that the directory actually exists. Then, we'll be able to do the same exercise again in the following way. The fact that you checked in this execution result is that if the directory is not found, the inline group statement is executed and the directory is actually. When it is not found, the following grouped sentences are executed, and you can see the execution result on the screen. As you can see, the inline group syntax starts with brace character and ends with brace character. All commands listed between the braces are treated as a group. When to use inline groups? The fact that you should not forget at the last brace character. It is a fact that you have to put a semicolon right in front of it. It's easy for us to forget, so it's necessary to remember. Conditional statements and loop statements are fundamentally essential in all programming languages, and we are familiar with them. Shell scripts also have an essential purpose of use. Let's see how to use the if statement through a basic example. If statement starts with if and ends with fi, and if statement performs a test. The test statement is a description between the keywords if and then. Must end with a semicolon. Commands can be used, and if necessary, arithmetic expansion, tests, and all operations related to tests are possible. The sentence between the keyword then and keyword else is executed only if it is true after performing the test. If the keyword else is omitted, then the sentence between the keywords then and fi will be executed. The keyword else contains commands that are executed only when the test result goes false. The following if-else sentence can be entered in one line. If you look at it, you can see that all new line characters are replaced with semicolon characters. If you are aware of this feature, you can say that you can code any number of if conditionals in one line. Let's look at various ways to actually enter if conditional statements. Usually we can code this style. In the case of style 1, if there are any differences compared to styles 2 and 3, the differences are clearly shown through the screen. We can use the script in any style we like by entering shell commands. Initialize the following shell variable. Another shell variable is then initialized to a string. Brackets have the function of testing. String comparison between a variable called Tom and a variable called Nero. Normal string comparison targets the order of strings by a combination of alphabets and numbers contained in strings. Compare strings according to the alphabetical order. The first letter is compared first, and the second letter is compared again. The preceding character is compared first, which evaluates whether the string is large or small. It is correct that the bracket characters used for testing are obviously the characters used for testing. However, here we can see the caveats of the brackets used as test symbols. Here we can see that the result is different from our intention. The reason is the angle bracket used here. The angle bracket is basically a symbol used to test whether the string is large or small. But because this character is also used in another meaning, the angle bracket is also used as the redirection character we are talking about. The redirection character used in the test evaluation formula is actually used as a redirect character rather than as a character that means that the test if something is greater than anything. Something is the author more than anything. In this case, you can solve it in the following ways. That's the test with 2 square brackets. In this case, the angle bracket is not a function as a redirection character, but is used as a test meaning of large or small. When I actually check it, it came out because the first letter used for the letter Tom is rather than the R used for the second variable. Therefore, the overall evaluation result is true. What about the next formula? Again, I entered it as an intention to test that the contents are same on the left and right. But in reality, the intention is beyond our expectations. You can also try to solve this problem in the following way. So why did the first test result differ from our intention? The reason can be said to be in this space character. In fact, Contrary to the user's intention, this input result was first interpreted in this way as the preceding input content. It's a point where you can fully predict what might have been a problem at any time. Therefore, from this example, we were able to see well that we should not forget to use quotation marks even when using variables immediately. As we can solve this problem as follows. The use of quotation marks is very important when using variables. We now need to pay attention to this example and look again to prevent such mistake. What will the execution look like? I'm not using quotation marks. Is it okay? Yeah, the advantage of using double square brackets is that you can omit the quotation marks. This is because the double bracket itself, which we now call square brackets, handles the comparison object inside it by actually recognizing all the white space characters. There is also no problem in using this. The reason is the same as the previous explanation. That's the methodology using brackets so far. I learned about the precautions for use. Here is an example command. It can be said that the variable called bar was not initialized, and exactly an empty string was initialized. I entered the following command for the purpose of saying whether a variable called bar is an empty string. How will the results come out? Actually, this input result would have been interpreted as follows. Since it's a variable with an empty string, it would have actually been interpreted this way. Therefore, in the following test statement that requires the left and right terms, the content of the left term was recognized as a result of omitting the input. So, we can try to solve this problem in the following way. When using variables, it is processed by entering quotation marks. When we input in this way, it is recorded that the term on the left is an empty string. So, we can solve this problem. There is also the following expression method. If you use test statement by entering two square brackets, you can omit the quotation marks. There are various meta characters used to implement conditional statements using the if keyword, and there are various examples of using the if command. Let's take a look at those examples. When you run the command, you see, this command is interpreted as follows. If the file named hello.txt in the current directory does not exist in the current directory, the following command is executed. This is a command that copies a file called hello.txt back using the copy command cp. If the test result above is true, that is, as long as there is no file called hello.txt.back, the following command will be executed. In fact, you can see that a file called hello.txt has been copied to a file called hello.txt.back. The meta character f used here is the character used to check whether a file exists Using this option, we can check whether any file exists. Other meta characters that can be used are meta character E used to check whether a file exists. Meta character F that returns true if the file is a regular file. Meta character D identifying if the file is a directory. Meta character H used to check if the file is a symbolic link. Meta character P used to determine if the file being tested is a pipe. The meta character R that identifies the path to the file. The file is readable by the user. The meta character S that the file exists but is tested for empty files. If FD is open, the meta character T that even checks whether the file is currently in use or not. Meta character W to check if the file is actually readable. If you use the following meta characters, I think that testing of conditional statements using if will have more diversity and you will be able to promote convenience. Let's look at the following command example. Conditions using if as follows. When should I use it? Only when the result of the first execution is false. Only when it is false. So is it true? When false, it becomes true. So the next sentence will actually be executed. These conditionals are usually effective when used in script files. When executing this script in an environment where the user has not entered any arguments or is not satisfied with certain shared requirements, it displays an error message that invalidates the execution of the script the user is trying to execute. It can be used for the purpose of terminating the execution of the script that actually terminates. Let's look at an example of using another if statement. Checks whether a file list exists in any path. If there is a file, a message indicating that the file exists, and if the file does not exist, a string of no files found is displayed. We can implement the if statement using the following expression method. Try running a script file called sleep.sh. You can check the script file running through the following. I wrote a script that checks whether the script file is currently running. Use a test statement to check whether the current script is running. If the script is not running, I am writing a script that will display a message that it is not running. The script is currently running, so a message saying that the script is running is displayed on the screen. Here, meta characters are used to compare integer values greater than or equal to. GT indicates great and EQ indicates equal. It is a meta character that is a combination of two letters. When the value on the left is an integer value rather than the value on the right, the result is true. If so, let's kill the currently running process and run the script again. After terminating the currently running script and checking whether it is actually terminated. When you run the script you ran again, you made one mistake. I missed this command. I made a collection and I go back to the test. It is printing to the screen that the script is not running as expected. Meta character X to check if the file is executable. Uppercase meta letter O confirming that the file is currently owned by the user. Uppercase meta character G to confirm that the file is owned by the group. Meta character -nt to check the date of the files on the left and the files on the right to see if they are newer. Meta character -ot to check which files are older in the file on the left and the files on the right. The following meta characters exist. Meta character G to check if that string is empty. Meta character N to confirm that the string is not null non-empty string. Meta character equal that checks whether the string on the left is the same as the string on the right. Meta character exclamation mark equal sign to check if it's different. Meta character left angle bracket, right angle bracket to determine which of the left and right strings is greater. The meta character that is totally true only when both expressions on both sides are true by and combination of the evaluation expression on the left and the evaluation expression on the right. If only one of the two expressions is true, the logical sum that leads to the overall true O, or meta character exclamation mark that reverses the result of an expression. Logically, it has function of not. The meta characters EQ, NE, LT, GT, LE, GE used to compare the left and right integer values. There are also meta characters for testing integer values. We use brackets in conditional statements using if, and we can test using two brackets. The meta character continues like this. Equal used to compare left string and right string patterns. Equal symbol can be expressed by writing down 1 or 2. The result is the same and performs pattern matching. However, this equal symbol refers to the equal symbol when two brackets are used, so if it is a function of string comparison when one bracket is used, the equal symbol used when two brackets are used is used for the purpose of pattern matching. So you're going to use global pattern matching. It's a similar expression, but you can test what's not the same by putting an exclamation point in front of the equal sign. You can also use a regular expression pattern. You can write a string on the left and a regular expression pattern on the right. These are all meta characters used when using two brackets, and we are looking at their contents. If necessary, you can put parentheses around the expression so the evaluation occurs first. When there is an evaluation expression on the left and an evaluation expression on the right, you can write two ampersands or two pipe symbols to end and or condition each. Although it is the same evaluation, you can implement the evaluation expression using one square bracket, and you can use the evaluation expression with two square brackets. Try running the following script. You can see that there is difference between when the argument is not entered and when it is entered. In the case of a script, where the script must receive an argument to pass, you might be able to prompt the user with the following text. In the case of a script, where the script must receive an argument to pass, you might be able to prompt the user with the following text. By doing this, you can give the user the right feedback so they know how to use the script correctly. Try creating a script that can print out a string message like this that tells the user to collect it by entering an argument as follows. Loop statements, which are essential in almost all programming languages, also exist in shell script. While loop and for loop are typical examples. Here is an example of a basic for loop. A test command is placed between the while and two keywords, and the test command must end with a colon at the end. The test was given an example in which the result was always true, but the command between do and don't would be executed repeatedly, over and over again, because it is always true. Check that the text hello world appears on the screen every second. Let's look at another example. In this example, the alarm alert beep sounds repeatedly at 1 second intervals. This example is an example using a for loop. The commands between the keywords for and do are listed, and the number of iterations of the loop statement is determined by the content of the test statement. One by one listed in the keyword, it is read as variable called no, with the corresponding element information. The loop statement is repeated until all the information in the enumerated list between in and do is finished. After execution, we will check what the current evaluation results contain. Let's look at only the echo part used in this example. Here, something called brace expansion happened. According to brace expansion, variable characters used inside curly braces must be treated as able in order for the characters to be expanded. So you can see able, which was used in for loop. The previous sentence can therefore be thought of as the following command. The list information used in the for loop is read into a variable called no, one by one list separated by white space characters, and the loop is repeated until all visible elements in the list are exhausted. I have shown 2 or 3 typical examples of while and for loops, and you will see more examples of for and while loops in future examples. Create a function that adds from 1 to 100. Declare an array like this. Try to print the contents of the array. Access the elements of an array using a for loop. However, in the access method, you do not write the row name and use the exclamation mark to get the elements of the array, but read the array reference index. Here is an example of how to access an array using an index value. If the word pen is found in an array element, it is replaced with a null string. You can see that the elements of an array called pen have disappeared. You've confirmed that the for loop works just as we intended. ImageMagick is often referred to as a command line for a sharp program. Image editing, filters, images, compositing. A program called ImageMagick can be used for a variety of purposes. Being able to use it for the command line is a big advantage or difference. Install ImageMagick using subtitles in the video. After installation, try the following practice. After installing ImageMagick, you will be able to use the following commands. Let me show you for a moment what you can do with this command. You can see that there are no files on the desktop of the current Linux user other than the shell command directory. After running the following command, you will see an image file created. The file name would have been created with the name en.png. You can see that the file was actually created well. In the same way, you can see that another file is created with a little modification. Try creating an image file as you can see for each country's locale. Try using a for loop. Please use subtitles for locale information. The for loop statement can use the for loop method used in the C language in the shell. Let's look at the following example. Initialize the string. Write a for loop. It is very similar to the for loop used in the programming language C. If the starting value of the loop I and the test sentence I are smaller than the item on the right, the loop will rotate only if this condition is true. The I value increases by 1 for each loop rotation. It is a command that extracts one character from a string and displays it on the screen. You can see that the text "Hello World" is displayed on the screen one by one. You can do this with for. There is date command to process dates. You can output formatted as follows. You can print it year, month, and day. You can also print it in the following way. Let me show you another example. You can make the time come together as follows. You can see another example of printing the time again. You can also see this way of printing the time. Finally, formatted output like this is also possible. When we print the date command, several formatted outputs are possible, so we can use them as needed. When you run the script, make a clock that looks like this. This tutorial introduces important syntax that anyone can make mistakes when writing shell scripts. There is a list of files in the directory as follows. Try to delete the file by looking for a list of files with an extension of MP3 in the directory using a for loop. Was it erased normally? We can see that it failed to delete the file. What is the reason? Check out the reason for the failure by looking at the example next time. You are trying to find all the MP3 files in the current path using globe and delete the files. We will see if the following contents can actually delete the file. Will this method succeed in deleting files? Again, we can see that this method has also failed. So, how about this way? You can see that all files that were shown in the current path have been deleted successfully. So I tried to delete files in 3 ways. 2 methods failed, and you saw that only the last method was used to delete files. What could be called an error in the method we did earlier? Let's check in order. The first method I used first. Let me point out the case problem. At the first glance, it doesn't look like a problem. However, the next extension currently used in a way called command substitution should be expected to be a list of space-separated files called for whom the bell toll to come in place of this extension currently in use. The contents of this list of the for loop are treated as separate words from the whitespace character called whitespace. Therefore, contrary to our expectations, this file called for whom the bell toll is generally recognized as a single file, so it is not input one by one as variable in the loop statement called file. Actually, one for whom, one for the, and one for val are entered as individual elements one by one. Therefore, the following error will occur. Because it's handled like this, it didn't really help us to use the file deletion quotation marks. So, what was the problem with the second failure method case? Handling the quotes looks good, but this can also lead to new problems. The first file, the second file, and the third file are all treated as one file in quotation marks. There are actually 3 files, but in the for loop, the whole would have been recognized as a single file as a string. Therefore, this method also results in a failure message stating that the file cannot be deleted. So, what was the right solution to not cause this problem? Right, it was the third method, but in the third method, we did not use quotation marks and displayed only the globe. We should remember this method well. The caveat is that you should never use quotation marks. Globe, for loop, no quotation marks, you must remember. Also, remember to use quotation marks when deleting files. If you accidentally omit the quotation mark, you will see that it is treated as word separated by a space character. As you can see the for loop, when using globes, there are 2 important points when using quotation marks, and if you remember them, you will be able to avoid mistakes or errors. As I said, I once again emphasize that you should not use quotation marks when using the globe. Make a backup file of the image files shown in the current path. Create a loop statement using a for loop. The command 6 is useful for generating numeric serial numbers. I was able to print the numbers from 1 to 10 on the screen by entering the following command. The following expression is also possible. Starting from where the last 10 numbers can be printed on the screen in increments of 2. Immediately, only even numbers were drawn and the printed effect was created. There is also an expression like the following. I was able to get the numbers separated by commas as separator. Starting from 1, increments of 10 could be printed in increments. Of course, you can do it this way too. Finally, the sec command decrements and prints out. By using the sec command, we are able to make the numbers vary. Write a script that prints out permitted numbers like this when you run the script. Please use a for loop and write it using zip printf. Try typing any letter. The following syntax, which receives input from the user and performs the corresponding action according to the characteristics of the input string. In the C language, so-called switch statements can be used with the syntax called case in the Linux shell. I'm looking at the example right now, and the letter ABC entered by the user is not a number. Therefore, it is outputting to the screen that is not number. Using the same method, I try to enter the number once. It is confirmed that it is number according to the case statement. It is outputting that the user input is number. Case statement basically starts with case and ends with ISA, embodies this letter called case at the end. The user input will be saved in a variable called reply. I check what pattern the value stored in this variable is, and if the pattern matches, print it as a digit, and if there is no match for the pattern, I use the wildcard group as the contents. Other characters are printing as not digits. Check that the POSIX expression is being used here. It's like the POSIX pattern. Only in the case of numbers, the output will be digits. The case statement has such a feature that it can be processed according to conditions like the case you saw now. When using, basically write the pattern expression for the condition and write the command to start when the pattern expression for the corresponding command matches. When using it, it is important to remember that the end of the command must be 2 semicolons to indicate the end of the sentence. So you must not write 1 semicolon, but 2. Since 1 semicolon is used to separate commands and commands, it is good to check that 2 semicolons as basic syntax for case statements that correspond to switch statements in C language. Try creating a script that prompts the user when the following script is run and prints the following output when the user presses Y or lowercase n. Try pressing the lowercase n implemented to print uppercase yes when lowercase y is pressed and uppercase no when lowercase n is pressed. Here, use the case statement and implement it using the read command. When the user presses a letter that is neither y nor lowercase n, when the user presses any letter, make the following output. Let's take an example of a script file like this. I'm giving an example as a Python Anaconda program installation script. The Anaconda script file looks like this. You are seeing an example of actually using the syntax of the Linux shell command ops getops that I want to explain in this script file. The getops syntax is commonly used by us to process arguments fetched from the user in a script file. The user for receiving arguments to the user is to use hyphens to receive arguments as follows. Individual parameters can be defined and used by the user, and user-defined parameters information can receive additional parameters. The argument P will be able to take over what is called the associated accessory, argument 1. When processing the following, according to the getOpt syntax, you can write down the hyphenated argument BFH like this. If an individual argument has another argument as an accessory, put a colon to the right of the argument. If the argument has one more subargument, the argument can be written down side by side like G and colon. Then the argument G has another argument. The parameters passed by the user are analyzed by getOps, and the parameters are read one by one through a loop statement by a variable called x. So getOps checks if there is parameter B passed by the user, checks if there is F, checks if there is H, and checks this parameter once every time it goes through the loop. The passed argument is interpreted in the case statement and the corresponding action takes place. It can be said that getOps provides a very convenient way to pass arguments to the user, as in the example you saw now. When the argument received from the user passes an embedded argument, the following message is displayed. In case of misuse of arguments that receive additional options, it can also be used to inform the user of the correct usage. When the user correctly passes the argument, it is possible to receive appropriate processing according to the content. Therefore, by providing an efficient way to receive user feedback, we will be able to use getOpt when writing scripts if necessary. I have the following arrays. This is how we create a prompt in the use of the keyword select we are going to run. In the future description, you can guess what the variable PS3 is used for. Select syntax is very similar to while, do, don't, or for, do, don't. You have completed all the select statements. The contents of an array called the movies are moved to a thing called the movie for each element, and the contents of the movie are expressed as being selected. Then let's check what happens when we run the following content. The select command, as you can see, is such a tool that prints the contents of the menu to the user and allows the user to select a menu. As you can see in the example, please create an array and implement the select statement in the correct way for that array. The input array content elements are output to the user in a menu format according to the serial number. Prompt messages defined in PS3 are exported to users. The user enters the desired item using the number according to the screen contents. I'll press number 1. It comes out that the menu is selected, and once again prompts the user to input. This time, I'll press 3. The correct input is fed back to the user, and the user can exit by pressing Ctrl+C when they no longer want to type. Let's look at another example. This time, the array element is also created as follows, and unlike the previous example, the expression none was added at the end. We will also create a PS3 prompt and write a select statement. Make sure that the select statement uses a syntax called case. If all input is finished and you look at the main content before executing it, assuming that the user input was none, the corresponding none would mean that no movie was selected. Then the break statement was used together to escape this loop. Therefore, if you select another movie title, the title, movie title, and the word select will be displayed together. If the user selects none, the corresponding string and user prompt will no longer appear, and all processing statements will be terminated. Let's run it to see if it works as expected. First, try pressing 1. Try pressing number 2. Try pressing 3. Finally, I try to press 4 because it says none, so that I don't want to select the movie. When pressed, the command is executed, and you can also see that it exits the loop. We can use the select and case statement to expose the respective menu screen to the user and use a method to receive user input flexibly. Using the command declare, you could create an array like this. Declare the second array. Let's combine and print two arrays using a for loop. Let's print it as watermelon, blue, mountain, superstar. Let's write something like this and see if it actually works as expected. We can create and use something called an array like this, depending on our needs. The default usage of arrays is declare option A equals to tens and write down the list of arrays by enclosing the desired elements in parentheses. Array elements must be separated by white space. Arrays are a way to express all arrays in the case of a for loop in actual use, and $, braces, row names, brackets, etc. are utilized. Here we use it to represent all the elements of an array. Individual elements can be accessed and used as in the following example. Write down the row name and index value side by side to access the array element. When declaring an array, you can also declare it using a command called declare. You can also omit declare and declare an array like this. Write down 10 times, write the equal sign, and open parentheses to actually start the array. It is important that all elements are separated by a space character. It is safe to enclose the individual elements in quotation marks. An array called array has been declared, and the following for loop is written to access the array elements. Since it is a popular for loop expression method, this content conveys a lot of useful information when writing a for loop. We have finished typing, and we will try to predict what will be displayed when the following is executed. If you look at the contents of the array, you can see that all strings have some regularity. Sky, blue, snow, white, night, black, apple, red. Some nouns have some color combinations. After extracting individual elements from an array called array, the first word separated by colon is stored in key. This is an example of storing the color information separated by colon in value and reprinting the contents in the desired format of a method as follows. Then let's see the execution result to see if it works as expected. This example shows the benefits of using arrays and for loops. Let's check out some characteristic aspects. First of all, let's look at how to access each array in a for loop. It represents the entire list of arrays. The first checkpoint is that the array elements are read into a variable called object, one by one, using the keyword in. The second thing to know is the fact that the @ used quotation marks when referring to the arrays used. It is absolutely essential to remember to use quotation marks when referencing arrays in a for loop. If this is not a problem in this example right now, it is important to remember that omitting the quotation marks may result in word separation by white space characters. Next time we remember, thinking about its importance, that if there was a space character in the element, it could cause a big problem if we don't use quotation marks. Let's look at another example. I want to get a list of all pies in the current path through the command ls. It looks similar, but the first command is a simple string that is stored in a variable called files. The second, files are stored in the form of an array. The third shows how to initialize an array using a globe. We have to remember that when fetching a list of files, we must use the globe to read them. In the first case, in the second case, both create exceptional circumstances and always have potential problems that will lead to errors. Therefore, we must use the safe globe syntax to initialize the array. The following is an example of a file named tech.txt. The file contains a list of words separated by commas. Write the script so that when you run the following script, the following file is created. The file content should look like this. After running this script, create a corresponding file with an individual file name using the string in the tech.txt file. Write a script file that works that way so that the file contains a string with the following schedule format. Basically, the grammar to use requires a read command, for loop, array, etc. You will have to use the built-in keyword ifs to handle comma-separated strings. There are files with the following MP3 extensions. Search the file for this file, find the file, and delete it. Here, a command called xargs is used, and the search result is passed to the next command, rm command, by xargs. Run it to see if the file was actually deleted. You can see that none of them have been deleted. Why wasn't it deleted? To check, try change the following command slightly. Why finally delete files? You will know if it's not. The file we are trying to delete is characterized by whitespace characters, and in certain files it also contains newline characters. Therefore, normal file deletion was not possible. Let's go into this in more detail. After finding the file, try hex dump the file name. It is possible to check through the hexa value that space characters are included in various places in the file. And in the case of certain files, you can confirm that the line feed character is also included as a line feed character. How can you do this when you say that you must use the find command to find and delete it? The find command has great options for this. It is called print all, option to enter null character at the end of all strings and at the end of search results. If you print it with hexdump using this option, it is easy to think that there is no difference compared to the previous one. But if you look closely, you can see the null characters are recorded in the string at the end of the last MP3 in the list of all files. This is thanks to this option called print all. If you put the following option in the following command and pass it through the pipe to the next command, you can use this feature to treat the end of the string as a null character to distinguish between the beginning and the end of the file. So if you use the following command to print, you can separate the parameter list previous passed with null characters and pass it to the next command. If we just use this method, we'll be able to do the following. It will also be available to delete files. It takes a list of files separated by null characters, so xargs also treats the argument as a separate word. If we pass all the words separated by null characters to the rm command, we'll be able to delete the file, which is our expected purpose. You have seen that the following files that contain not only space characters, but also line feed characters can be deleted normally. So, when deleting a file, use the print 0 option in the finding command when deleting after searching for a file. Don't forget to enter option O when you pass it as a pipe and receive it with the xargs command. Then you will always be able to search and delete files accurately. Learn about the various uses of the find command, which has a large frequency of use in Linux. The following command is used as such a command that only searches for script files with the extension sh in the current path. Features are only searched for in the current path. Even if there are subdirectories, script files in the subdirectories are not searched. Let's increase the max depth by 1 level. You can see that it finds the script file in the subpath md5sum. Suppose you want to find the backup file with extension back on the current path and see its detailed information. Then, write down the search target path of the find command as follows. Write down the file name using globe and search. In the find command, a separate option called the exec is described as follows. Because of the role of this option, the search result is passed to the next command ls. Search results are indicated by curly brackets, which are applied to the ls command detail, view command targeting the search results. When using exec with the find command, you must indicate the end of the exec command ls by writing a backslash in a semicolon to indicate the end of this command at the end. This confirms that the find command has ended. If you run it, you can see that it lists only the backup files correctly. This type of command is also used as a function to delete a file with a slight change as follows. However, This command should be used carefully. This is because it is impossible to recover files with rm in Linux. If you want to find only directories in the current path, you can do it with the following options. Write down the type of file and display it. It only searches the directory. If you want to find hidden files, you can do it in the following way. You can search for files starting with the dot only in the home directory path without searching the subpath. Finally, you can search by combining two or more with the find command. If you want to search for a file with a permission of 644 and ownership of a user, process it using parentheses as follows. Don't forget to escape the parentheses. When you use AND combination, enter the following and write two expressions. This is command to search for a file that meets the following conditions and pass it over to a pipe to actually view the contents of a file with the view details command. In addition, the find command provides a variety of search methods. Use separate data links to learn how to use the find command. The input and output of the bash script is a complex topic. There are many ways to enter the script as follows. First, command line argument. Second, environment variable. Third, file. Finally, it is a pipe or terminal socket that can be represented by a file descriptor. We can say that you can receive input in various ways as follows. Then, what is the output method? It is also possible to output in the form of a file. Secondly, anything that can represent a file descriptor. Third, other programs can output as command line arguments. Or you can pass it to another program as an environment variable. If we are aware that there are various types of inputs and outputs as follows. When writing a script, it will be available depending on the purpose required. I have an image file like this. Suppose you want to change the extension PNG to JPG. We use a script created for that. In order to distinguish PNG from the existing file name as JPG, I will enter the extension in uppercase so that the changed ones will be noticeable. In fact, check if the file with the PNG extension has been changed to JPG. You can see that the extension name of the file has been changed normally. Then, we'll learn how to pass arguments to the script while analyzing the script file next time. If you look at the contents of the rename.sh script file, you can see the expression $1 first. It is displayed as $1 instead of the word PNG, the parameter passed by the user. In the same way, the uppercase JPG, which was the second argument, is changed to $2, and you can see that it is being used. In this way, the argument passed by the user is $1 from the first argument, and $2, the second argument, can be passed in this way. When the number of arguments exceeds 9 and becomes the 10th argument, from then on, we mark with 2 digits, and we must remember that we have to use curly braces. We call it positional parameters such as $1, $2, etc., which are used to receive these parameters. I'll add a new locale. Enter password and confirm locale has been added. Try to print the date. Current locale values are in English. Enter the following to print the date in Korean. The environment variable length takes effect only for the date command. If you enter the date command, you can see that the old locale information is processed as it is. In other words, it is not changed by environment variable. Try typing like this. The environment variable value has been changed, and you can see that the date information is displayed in Korean according to the new locale. If you log in again after log out and enter the date command, you can see that the existing locale value has not changed. Through this, we can understand that the environment variable actually changed by the following command is only valid in the terminal currently logged in. If you run a separate shell again in this state with the changed value of the environment variable as follows, you can see that the environment variable is inherited from the child process bash. So what about inside the script file? I will write a simple script file. It also works in the script file, so you can check that the locale value is valid. What about in a subshell? You can check that it is also valid in the subshell. Then, let's do some interesting topics. Create rank 1 as a general variable, not an environment variable, and modify the script file slightly as follows. And after checking the current rank 1 value, try running the script file. Unlike rank in the environment variable you saw earlier, in the case of the general variable rank 1, the contents of the script file and the execution result on the actual shell are different. In other words, you can see that the general variable rank 1 is not inherited from the script file. Then what will be expected next? Rank 1 as a general variable is also valid for subshells. If so, only one question remains. What is the way to enable rank 1 as a general variable in the script file? This is possible by exporting the general variable. If rank 1 is exported as a general variable, all child processes running on this shell will inherit. Of course, this includes the scripts running in the current shell. Let's run it to see if it actually works. Yes, rank 1 has been verified that the exported rank 1 is also valid in the script file. Therefore, export can be set to be valid command in the following situations. Even if you enter the imp command to view the list of environment variables, you can confirm that the exported variable rank 1 has become an environment variable. In other words, because the environment variable itself has the property of inheritance, everything has this property. In short, the final conclusion of this time is that the exported variable is an environment variable. I have summarized the variables and export, but this time, the scope of the variable is called the variable scope. In various situations, we will take some time to organize the scope of the variable. Create a variable year initialized with a value of 2020. After declaring the function, we will run the function. What is characteristic here is whether the variable value declared outside the function called year is indeed valid within the function. It has been confirmed that the variable year declared outside the function is valid inside the function. So, if we reset the variable inside the function again, will it be affected outside the function? Let's test it. In this case, you can see that the variable value changed inside the function is also affected outside the function. Create a simple script file and let's look at variable coverage in the script file. Let's run the generated script and check the extent of the variable scope. Print the variable value called year inside the script file, and also print the variable value outside the script to compare the value. It has been confirmed that the variables declared outside the script file are embedded inside the script file. If so, it would be a good idea to modify the script file slightly to see if it is affected outside the script file after changing the value in the script file. After entering the new year, we will evaluate the impact outside the script file. It was confirmed through the following test that the contents of the variable declaration in the script file are only valid inside the script file. We can think of shell script itself being treated as a sandbox. So, what about the scope of the variable in the subshell? As you can see, the variable year initialized to 2020 is duplicated even within the subshell. So you can see through the following example that the inheritance effect actually took place. And through this case, it was confirmed that the changed value of the inherited variable changed in the subshell has no effect outside the subshell. What is the scope of the variable in an inline group? Next time, we can change the example a little, and we can make it an example inline group. If we find the part using parentheses and replace it within curly brackets, it is an inline group. Remember to put a semicolon at the end of the inline group for inline groups. Let's run it. It is worth noting that the internal variable year changed inline group actually expresses influence even outside the brace inline group through the following example. This is not really surprising, since the inline grouping itself has only the effect of tying commands together. You can actually expect it to be natural result in some way. Finally, let's look at the range of variables in export. The variable called year is converted into an environment variable, and its execution range is estimated by printing the effect inside the script file. and the value of the variable outside the script. The inside of the script file called mydate.sh was processed as follows. The environment variable value changed to 9,999 in the script file actually leaves the script and has no effect. We confirm that one script file is being processed as a sandbox like an island in the following example. Knowing the scope of a variable makes sense in its own way. If you know the variables entered on the command line, variables used in scripts, variables used in functions, variables used in child processes, and their scope, we can prevent errors in the script we write to some extent and prevent mistakes, I think. File descriptors are similar to pointers to data sources, or a place where they can be written. When reading or writing to a file descriptor, you are reading or writing data from the file descriptor resource. Basically, every process starts with 3 open file descriptors. The first is the standard input device. You can write it stdin and use O as the file descriptor number. The second device is called the standard output device. It is called stdout and uses 1 as the file descriptor number. The last and third is the standard error device, marked as stderr and used to as the file descriptor number. Let's consider the concept of each file descriptor through the following example. If you enter the following command to print hello world using the echo command, you will actually use the standard output device corresponding to file descriptor number 1. The echo command uses the standard output device stdout. Then, let's look at the following example. In this case, the directory does not exist. If so, you will get an error message. These error messages are output through the standard error device. Finally, when you use a command that takes user input like this, we enter a key. The current command uses the standard input stdin. There is a technique called redirection in Linux. There is a syntax called redirection, such as saving the standard output to a file, or redirecting the contents of a file to another file. Let's find out about it. The angle bracket used here turns the stream of strings from standard output to a file. It does not actually appear on the screen, but the output result that appears on the screen is saved as a text file named figure.txt. We can confirm that as follows. You can see the same result in the following way for the output by the redirection operator you saw earlier. Remembering that you think the file descriptor number 1 we learned is the standard output device, we can easily guess that what actually used the number 2 in front of the angle bracket is what will actually be output to the standard output device. Therefore, the symbol for the redirection operator with the number omitted and the operator marked with the number are the same here. The following directory does not exist. Actually, the error message on the screen is redirected to the next file and saved. In this case, file descriptor number 2 indicating the error is used. you can see that the contents are actually saved in the file. When two rectangle brackets are written, the corresponding contents are appended to the file shown on the right below. When only one angle bracket is written down, if the file does not actually exist, it is newly created, and if there is, overwrites with new content. However, the angle bracket with two rests appears as a phenomenon in which new content is added to actual file content. You can see the actual added content as follows. We can see that both are saved to standard output as file 1 and file 2. Redirect can also be used to merge two files as such as. It is a situation where two files are printed using the cat command, but by redirecting, the two files will be combined with a new file name file. You can actually check the contents of the file, and you can see that the two files are merged. In this example, you can see that the direction of the redirect has changed, but a command that reads the contents of a file as read and echoes the contents back to the screen was used. The example you've seen right now can be seen as an example of using redirect file descriptor O. Normal message in the following case. Messages coming out to standard output devices go to Stephen. You can see in the example now that the error message is also redirected, and the standard error message is output by turning to the standard output device 1. In other words, the message from the standard output device is supposed to go into Stephen. Will be output to standard error also. Since the direction has been changed to standard output, virtually all messages are saved as Stephen.txt. The Stephen.txt file exists in the current directory, but the actual lucas.txt file does not exist. The grep command will try to find the word *words in the following Stephen.txt and lucas.txt files. But actually, lucas.txt is not found. Therefore, using the standard error device, not the standard output device, an error message would appear saying that the file does not exist. The error message is what you can see in this case, that the error message came out through the standard output device rather than the standard error device because of the redirection. I have the following image files. It is an image file that looks like this. Using a program called ImageMagick, we can select the color on the image we want and change the color value to the desired value. Let's do a fun practice. In the current directory path, type by extracting 10 colors of representative colors of color information used in the previous picture. The color list is not displayed on the screen, but is output using a redirect as a text file called colors. color information would have been saved to the file. Using the following command, we will create a script that sets color information and edits the color information into a new color information file. The contents of the color file, which stores color information, are read using the read command using a redirect, and a new image file is created based on the read color information. Please check the result after running. This is the original image file, and you can see that the specified color has changed. The changed shape is very diverse, so you can see that the color information has changed. In this example, you have seen how the redirect symbol can be useful when writing scripts. Commands executed in the current terminal are basically characterized by the fate of the process being destroyed with the logout or termination of the terminal program. For example, if a command called sleep is executed and the terminal program is possibly terminated, this sleep program is also doomed to terminate. It would be nice if we could run this process or program after logout or after terminal shutdown. With the command "hub," we can do what we want. Let's look at an example command next. You can run a script file called mydaemon using the command "nohub." When run, this script is a process, which is a bash process. Even after the current terminal is terminated, the script will not be terminated and will remain alive, ensuring the script's expected lifetime is executed. To check it, use the date command to determine whether the script has been executed before and after the script execution. Using a redirect, standard output is put into the trash. Standard errors are put into the trash, and the redirect input is processed so that no input is received. Also, it was run in the background to make a daemon process. Run the process with nohub as follows. Immediately terminate the process, and after a certain time. After 10 seconds, we will determine whether the process survived and worked. Processed, try to log out. After logging in, after a certain period of time, the current script execution time is displayed on the screen. 4:34, 24 seconds is the time the script was executed. If the script continues to run after that, we can check the information that has been executed after that through the log. Since about 10 seconds have already passed, we will log in again and check that the script continues to run afterwards. I remember 34 minutes, 24 seconds. You can check that the log is still left after 34 minutes and 24 seconds by looking at the following content. You can trust that this script file continues to work after logout. In the script file, the log was recorded at 1 second intervals. The script was written to leave a log for about 60 seconds. If you use a command called nohub in the following way, we can run a program that can be kind of a daemon process that can be run even after logout. It is very attractive if you can use shell script to create an installation script for the program you want. The following example shows how an idea. there is a file called hello world. That's C that we have created. Let's compile the following C code that prints a simple hello world message to create an executable program. The created executable is of course executable. To script this file to install, we go through the following steps. Convert the file into a file called tar. Check the checksum value. There is a script file called hello world md5sum.sh that you have already written. Open that file with an editor and transfer the current checksum value to the script. Put the md5 sum value as it is and put it in the body, as well as the actual command. And put it in the warning text. The file is modified, and the modified script file and the two previous prepared hello world, the tar files are merged. The merged hello world script file created using redirect is as follows when opened. This is a new script file that combines a script file and a binary file called tar. The script file is called the install script. Let's check if the shell script is working properly. Execution property must be present, so let's run it after granting execute permission. At the first glance, it doesn't look like a big deal. If you actually open this script file, you can see a surprising fact. If you look at the first half of the script file, you can see that it contains defensive code that checks the checksum value of the file included in the script and prevents the installation from starting if the checksum value is abnormal. The script file has a means to prevent hacking and cracking. This script file creation method gives us a lot of ideas and methods. If we want, it is possible to distribute the program I want through a script using the following principle. We'll think about this at least once. You say you want to keep a log file at the same time while looking at standard output or standard error output. A Linux command called T makes this possible. Let's look at an example next. The string specified by me, word, is passed to the command called T using a pipe. The command called T saves the string received through a pipe in a txt file called stephen.txt. Also, this string of standard output word helps us to get it on screen. Actually, it does not appear only on the screen. Its contents are also logged in a txt file called stephen.txt. If you run this command once again using a command called T, the existing contents will disappear, and the new contents will be put in stephen.txt. We think of adding a file at this time. You can also do this with options. You can add a string by adding an option A to the T command. If you look at the execution result, it will actually be the output result with the second line added. You can use redirections to log not only standard output, but also standard error to log and standard output. If the error message does not come out to the standard error device, but to the standard output device, it can be said that it is the result of the redirection. In addition, you can check the remaining records in the log. Anytime we can see the output result in real time and leave a log. This time, we will look at very interesting and informative content. This is the subject of here doc and here string. Let's look at an example next. The seed command was used to convert the string hello into the word goodbye. Seed command requires an input file. Here, the file is accepted using the syntax here document. It has a unique method. Here, a symbol that looks like a redirect is used. Actually, this symbol has nothing to do with the redirect. It itself displays the here document syntax. It is characterized by the angle bracket pointing from right to left, and the angle bracket letters are written side by side on two. Also, the word here is visible to the right of the symbol. After entering the keyword here, which acts as a kind of anchor as follows. Enter the enter key, and then enter the file you want to send to the seed command in the form of a string. Like this. You can keep writing down any number of lines you want. Like this. Write down as many times as you want, and you must start with the first column with the same name as the word you cut at the anchor. Like this. Quotation must be written in the same name as the word we anchored, and must be written in the first column. If you write a space or a type character, it is incorrect syntax. Be sure to write the word from the first column without spaces or type characters. This holds the last point of the anchor. The here doc grammar defines from the current word here to the occurrence of the same word here. The following strings are actually delivered as a file to a command called sed. So the name also expresses this by using a word that feels like a document file called here document. After learning it, you can actually see that the word hello has been converted into goodbye. Let's look at another example. Although we are currently logged in, we consider the Linux system we are using as a server, and this same server as a client. While currently logged in, try to connect to the host address 192.168.16.213 again using SSH. After you check the IP address of the system you are using, please try this exercise by replacing it with the IP address you will use. There is something unusual about this exercise, is that the quotation marks are used. Let's walk through the here document of this command called SSH and let us do something. The option R of the command called uname is the command to print the current kernel version. After all, the input is completed. I will complete the here document with the word here. you will see SSH behave as expected, and you will see the kernel version displayed on the screen immediately. And because of the effects of the exit command after writing it as a script, you would have logged in with SSH, printed the kernel version, and even terminated. Now then, there may be a number of questions here. It's not yet clear what the next here document will have. Now, let's take a look at the characteristics of the here document through a continuing example. This time, we run without using quotation marks. Now, there are parts that need to be looked at carefully, so I will tell you about them. Please check the current path carefully before executing the following command after SSH login. Also, please carefully observe how the path name at the time the script you are entering is executed. If you enter the password and confirm the exit, you can confirm that the path name is the same before logging in with SSH. Okay, so now I put quotes around the anchor so that I run the same script. Please observe the difference with the results immediately. The current path is a directory called desktop shell cmd in the user's home directory. If you pass the here document holding the next quoted anchor in the current path to SSH, and run it, check how it differs from the previous result. Now run. You can enter the password and see that the path is different from the example we ran earlier. As for the difference, the anchor's quotation marks were not taken, but one was grabbed, and the results of the two executions were quite different. The reason is simple. According to the grammar of the here document, the here document with quotation marks handles the variable used inside. That is, the environment variable differently at the time when expansion occurs. Here documents in quotes pass this extension to the process after the actual SSH command has been executed. So, since PWD environment variable expansion occurs after logging in, the PWD environment variable will be the path to the user's home directory, since the home directory of the user called user is default directory at the time we log in with SSH. In the previous exercise, quotation marks were not used, but the following command was executed with the expansion already expanded before the SSH command was actually executed. Therefore, the current path is shell cmd, since the command using the here document was executed next. The current path called shell cmd is expanded first, and the entire string information is transported to SSH in the document format. Even after SSH login, the same path was displayed on the screen. Therefore, we can make good use of this here document feature, put quotation marks as needed, and subtract quotation marks as needed. As you can see in this example, the here document enables you log out, and log out after creating some data or creating a log file on the remote server system you are using. Very diverse. Now, lastly, I will use the here document to supplement and explain what you need to know when using it. If you want to log using a redirect in a command where the here document is used, the redirect operator must handle it by writing it to the right of the word here that you set as an anchor point. And there is one more thing to remember. The anchor word does not have to be here. If you want, not here. Here 1 is possible. Here 3 is also possible. And the name here does not have to be used. Note that any name is possible. If you actually open the log, you can see that its contents are recorded. Let's say you create a function in a script file with terminal as follows, and when you execute the function, you want to pass information to the user by using a script file or guide as follows. Then we can do just this with here documents. Now let's find out how. Create a simple function as follows. I'm going to make it a here document, and I'm going to enter the content. The here document said that the anchor should be written with the same name at the end. Finish the function and check if the function works normally. The here document can be set to have another use. The here documentation also provides a useful method when we want to display a lot of strings to enter. When writing script files, especially when you want to deliver simple helper information to users, remember the method you saw in the example now and use it. And here documents will be able to provide you with a more useful, intuitive, and convenient method. Like here documents, there is something called the here string. Let's look at the following example. Send in file format using here string in SAD command. Unlike here documents, here strings use 3 anchor brackets. The feature is that there is no anchor, which is different from here documents. Also, use the string format instead of the anchor and pass the quotes normally. If you run it, you can see that the string code hello world must have been passed over by borrowing the file format. The word hello in hello world is replaced with the word goodbye. Let's look at another example. We define the field separator white space to redefine the comma to IFS. After the here string, a comma-separated string is passed to the read command. Words separated by commas are stored separately from C1 to C4 declared as an array here. In fact, you can check that here string is read normally through. If the here document uses the here string correctly for its purpose and needs, the expansion of many expressions in the shared script can occur. When I want to pass a simple file to a command, it would be nice if I could borrow the file type and link it without actually creating the file. I have a file that contains the following list of fruits. If you look inside the file, you can see that the same word is overlapped and repeated several times. If you use the command unique, you can override the same repeated content. You can see that the repeated words are abbreviated into one word. If you use the option, you can see various usage examples of the unique command. Shows how many times the word is repeated and how many times inside the file. Also, if you use the option D, you can print out only words that occur repeatedly. The word orange was used only once inside the current file, so it was not reflected in the results of the current option D. You can see the contents of a file called fruits.txt with a fruit name written on it. You can see a list of 5 different types of fruit. Use the command sort to view the list of fruits in sorted text. You can see that they are sorted alphabetically. Here is a command showing the result of command code do in sort. It is implemented using a pipe, and if you look at the execution result, you can see the result sorted in order of size in the file directory. You can see that sorting is done using the field shown first. Let's look at another example. Sort and reverse sort by targeting the file containing the fruit list. So you can see that the preceding letter appears at the end. The following is also possible using sort. It sorts only the third field, centering on the colon symbol, which is a characteristic of a file called password. Normally, the sort command sorts for the first command, but if you look at the execution result now, you can see that the sort result is output using this number corresponding to the third field as the sort target. You just need to carefully observe the third number. In fact, you can guess that sorting took place using the third number. Linux has a special type of file called a pipe. This special file can be created by the command mknod and has the following usage method. Enter the file name you want to pipe after mknod command. It doesn't have to be named pipe. It's just an example. Also, this pipe does not have to be created in the tmp directory. This is also an example. Please write down the file name you want to create as the pipe you want along with the path. If you write p at the end, the pipe is made by mknod command. This pipe is also called FIFO. Let's use the following command to save the string in the pipe. The string will have been stored in the pipe and immediately, the current execution state will be transferred to a state called block state. The definition of the block state is the state in which the current echo command is holding execution and has not been terminated. We'll launch a new terminal and actually trace what's currently in the contents of this pipe with the cat command. Open a new terminal and use the cat command to output a pipe in the tmp directory. However, before executing this command, it would be better to first look at the file list. A special type of file called pipe has the following file type fields. It indicates that the type of file is a pipe. Let's print my pipe under the path called tmp. However, in order to confirm the special situation when printing, I will show 2 windows overlapped. Now, if you look closely, you will see a remarkable situation. Enter. In one place called the pipe, a command is used to put a character, and on the other side, to check the string. The contents of a pipe are processed as if it were a normal file output. Actually, the contents of the file will be pipes. The text stored in the pipe is displayed on the screen, and at the same time, you can see that the command to save to the pipe previously executed has ended. Notice that this process was run simultaneously. The example you saw now can be illustrated as a conceptual diagram as follows. A string entered into a pipe called myPipe under the tmp path, and this string came out of the pipe by a command called cat. So the pipe will be emptied again. This pipe is not only used on the example right now, It is used for a variety of purposes. See also other use cases. There are times when we usually print the contents of a file and pass the output to the following command using the pipe symbol. This will be the main use of pipes. The contents of the file are put in a pipe instead of being printed to the screen. In this case, the pipe is called the pipe without a name. This is an unnamed pipe. It will be stored in the pipe, and its contents will be passed to the next command. Again, once the content has been passed to the new command, the pipe will be emptied again. Some examples include: it is possible to create a single processing flow using pipes. The result of processing from the find command can be passed through a pipe as input to the next command. This pipe can be used as many times as necessary, so you can create and use user-defined processing flows or workflows, and this is recognized as one of the most important advantages of Linux. By creating a processing flow for commands with individual characteristics, you can utilize the advantage of each command and enter the processing result of that command as a new command to create another processing flow. Image files exist in the following path. Let's check the list of image files. There are a total of 7 files. Files with the extension JPG, ZIP, PNG, TIFF are shown. Let's remember that there are 7 files in total. Now, secondly, check another route as well. This is the directory path where the image file exists again. Compared to the previous file, there are a total of 6 files. You can see that only the file named candy.jpg does not exist, and all others have the same name. In the first execution path, there is one more JPG file called candy.jpg, which is the difference from the file list in the command executed later. Now, we did this manually as follows, but there is a command called com, which is a useful command in Linux, and you can easily check the difference information of the directories by using this command. Let's see the order. The com command is a kind of command that compares and prints the contents of 2 files. It has options, and options have a unique name of 1, 2, 3. In the current example, options 2 and 3 are being used. Option 2 compares the contents of the 2, but this is exactly what file 2 says 2 is the second listed 2. Do not print anything in file 2. It means like this. Also, the 3 written in the same end combination compares the contents of 2 files, compares the contents of the first and second files, but does not print the lines that exist in common in the 2 files. As this meaning, you will remember the message that appeared on the screen when you ran the ls command. If you use this content as a command called process replacement, the result printed by using sorting. Process replacement has the following unique syntax, which is characterized by the appearance of parentheses right after the angle bracket. Any command can be used inside these parentheses. The feature is that the execution result of this command is executed first, and then it is executed as a process. In the same way, command substitution, which is the second com argument, is also executed as a process. The execution result is immediately passed to the com parameter. The command called com is to receive 2 files, So the replacement of the first process is delivered in the form of the first file. The second process replacement is passed to come as the qualification of the second file. The meaning of 2, as described earlier, refers to the second file, not the first. In other words, option 2 means that what is in the second file is not printed. 3 is the same meaning that what exists in common in both files is not printed. Considering that com is the purpose of receiving two files and outputting diff values. After all, the meaning of 2 and 3 means that they exist in the first file list, but not in the second file. Therefore, the execution result is predicted that cand.jpg is the only difference between the output of the first file and the second file list. From the sorted output result, you can expect only this file result to be displayed. Now let's see if it works as expected. Nicely, only the word candy.jpg, which was present in the first file, but not in the second file, was printed. Now, the purpose of this exercise was to learn that the command called com is actually process replacement. Process substitution has the advantage of being able to concisely express the situation that we have to write in multiple lines. It also has the advantage of making coding conciseness and intuitive readability. Let's look at another example. The current path is directly called images, and there are lists of files as they are now. Another example of using process replacement. You can see that the search result for only the JPG file searched with the find command by redirecting is transferred into the while loop using process replacement. The order of execution is preceded by the while statement, and process replacement is performed first. As the qualification of the file, it will be delivered as a read command corresponding to standard input by redirection. The read command will read the contents of the past file line by line and process it. So, for the purpose of this command, it has the feature of such a command to check the number of JPG files. That's what I++ represents. It was an example of such a command that confirms that there are two files with the JPG extension. The current example is an example that shows what is called the subshell. Now, subshells are characterized by the use of parentheses in front of the command. Subshells are differentiated from traditional inline groups in that the group selected for that command is executed as a process, as can be deduced from its name. In this example, numbers between 100 and 110 are used one by one in the next loop statement. The number is added and saved as a file called num100 in units of one number. The action does not end at once, but occurs every second. The following process can be expected to take a total of 10 seconds. Then we will run this example for the following scenario. Execute the following command and immediately use the command called tail to monitor the trend of the num100 file that will be created using the F option. The purpose of this lab is to determine whether a process that runs for 10 seconds is active or not. Let's try to command the process to run in the background. And I will immediately monitor the change of the file with the following command. It was too fast, so it seemed like 10 seconds was too short. If so, we can change this example a bit and try it again. This time, increase it to about 200 seconds and do the same exercise, but the number starts at 200. It will run for a total of 20 seconds. The method execution is the same and the current process is providing that it works. This is what I call a subshell. Let me show you another example using the subshell. This is a representative example of using the subshell. Move to the desired directory, pass and compress all current directories into anonymous files only if the path is successfully moved. In other words, anonymous files are marked with hyphens. This hyphen can be found again in subsequent commands. The result of running as a subshell is passed to the next subshell using a pipe. After moving to the desktop, decompress the file received through the pipe. This command is a good example of the harmonious characteristics of subshells and pipes. If you see the contents of the directory called image on the desktop when running, this command can be judged as successful. I was able to see that the files were actually moved to the desktop because of the result of the next command. The files bundled with tar were delivered and extracted. This command is also very useful in practice. It has an advantage when the number of files is rather than the simple cp command when moving and copying the contents of a directory to a new directory. In other words, it has the effect of shortening the copying time. When writing scripts, we often define and use functions or something like that. Why do we use functions in many programming languages or scripts? Many programs, including scripts, become difficult to reuse unless we use functions. The fact that we create a function implies a willingness to reuse a function that has an independent function for future needs due to the nature of the function. Also, if we implement the contents as a function on a functional unit, the readability also improves. Now, check the features of the function through the following example. Create a function named sum and create a variable with the same name. Create the integer variable sum using declare. I have defined the function and tried to call the function like this. A method called command substitution was used. The currently used command called sum is a function. Arguments 1 and 100 are actually passed to this function. For user purposes, it will be a command that accumulates and stores numbers from 1 to 100. The execution result was 5050 as expected. Now let's look at the features when using a function. The first argument can be accessed as $1 as the first argument. The second argument approaches $2. Now, the second function can start with the function name, or you can use the keyword function in front of it. Of course, it's not necessary to write it down, so in the example you saw earlier, the keyword function was not used. Parentheses basically indicated that this is a function. Don't write anything in parentheses. If you've seen the form of a function in an existing programming language, you will remember the argument expression in parentheses. In shell script or shell programming, there is no less than anything within a parenthesis of the function. The start of a function begins with a brace. It can be called the beginning of the function body. Remember that the rest ends with the same curly brackets, and you put a semicolon right before the curly brackets. Prevent your minor mistakes. When using a function, you must define it first and then call it. If you call it first and define it later, it won't run. It's also something to be aware of when writing scripts. Using functions increases readability and reusability in the case of highly complex scripts. So if possible, rewrite what you think is useful as a function. Parameterize the next passed value 1, 2, 3, 4, 5 using the set command. If you look at the execution result, $hash means the 5 passed arguments. The number 5 is always greater than 0, so it is true. So the following statement do will be executed. The first argument 1 is displayed on the screen. Running shift 1 actually shifts the argument one by one. So the second argument is actually the first argument here. When the loop runs for the second time, the number of arguments is changed to 4, and the first argument is the second argument, which is 2. The shift command is a command that produces the effect of shifting the parameter list one by one. The following examples can be said to be the characteristics and uses of the typical shift command. Working in Linux environment, we sometimes see commands like this. This is the famous command called source. Using this command, when executing the bash file as the target, the source command has the effect of actually executing the script. Then, bash is also a script file. What is the difference between running the script file in the following way? Run about its content. The bash script file currently consists of following contents. You can see that the file also contains variable declarations. Like this, you can see that environment variables are also being used inside, but these environment variables are destroyed after running the script. When the script is executed using a command called source, the environment variable declared inside the script is not destroyed after that, and its value is maintained by exerting influence on the current shell. Therefore, all inline, command line, and terminal commands that are executed in the current shell can be used by the script inheriting the following environment variables. This command, called source, performs the same function as this dot mark. You can think of source and the dot as the same function. Let's look at an example command like this. Run a command called sleep as the number of argument 1000. For the time being, the sleep command will not end and will remain for a certain period of time. The currently running process is executing commands with the file descriptors all want to open, including standard input-output devices and standard error devices. Therefore, this point where the cursor that is currently displaying the prompt blinks indicates that the sleep command is currently being executed. In this state, all text information entered by the user is accepted by a command called sleep. We call this sleep command, which is currently holding terminal input-output control, as a process and running programmed process. When we press in this state, a so-called signal is created in Linux, and the signal is delivered to the sleep corresponding to the current foreground process, and the process is terminated by default action. The basic rule of the Linux operating system is that virtually all processes are designed to terminate when a signal is sent. Let's run this same command in the background. To run a command in the background, it is enough to add an ampersand at the end of the command. When executed, the process displays what PID is currently operating on the screen, and the process runs for a set time. There is a way to raise the process back to the foreground process. You can do it with the command FG. This command to run as a foreground process works as such a feature that brings the most recently entered the process to the foreground. The process that started in the background comes back to the foreground and grabs the console I/O, and the prompt is also showing it. You can suspend this process that is currently running at the time you can do it using. You can see that the process is stopped by pressing the shortcut key, which is also made possible by a signal. The stopped process can be resumed by using the FG command to resume execution. You can check that the process is not currently running through the following command. It is currently being stopped. Let's run that process again. If you use the BG command, the process will resume running, and the process will be running in the background. Depending on how you put it up in the foreground process, we can reprocess the foreground and stop it at any time by pressing the Ctrl G if we need to. Let's run the pre-written script file. The usual script file you see is described as follows. I have a function ready. This is a simple script file that prints out the following plain string. Function calls are taking place somewhere in the middle. Now let's run this script file. It is running like this. We will see how to debug the script file. Open the following file and write the following set command with Option X. This alone allows us to do basic debugging. Try to run it. If you run it, you can see which line is executed every time the line is executed, and the original text in the actual script and the execution result are displayed together. So we will be able to easily track this with this simple command whether which parts of the script file are executed sequentially. If you want more specific debugging methods, please keep watching the video. If you enter the following options, you can also print the line number in the script and the function name if it was an actual function by the effect of the PS4 environment variable. If you wish, you can also print the file name on the screen, but the file name is excluded from the script file shown in the current example. Now let's check if it shows the intended purpose when actually executed. If you run it, you can see that the line number is printed together, and if it was a function, you can see that the function name is also printed. If it is not a function, you can check that the line number is output by default. Now debugging can also be done in the following way. You can also execute the script file in units of one line using a thing called trap. When run, will run to the user line by line ask. If you hit enter, you can see that the line is executed and is waiting for the next command. It's kind of a single step because we can make it run every time we hit enter. It can be said to be a very beneficial method and can be used if necessary when debugging. Using the clone command, you can run the script. You specify at the desired time. Also, the script can be run periodically, so just schedule it, and the script will run for you at the specified time. How to use clone is as follows. First type clone tab E. At this time, write down option E. When you run it for the first time, you will be asked which editor to use as the main editor. In this training, we will use beam. Dial number 4. Basically, if you run Chrome tab, you can see the contents that are written with each usage. Enter the following for testing at the bottom of the line. Enter the following. Assuming that the script file we want to run is in the following path. Write down 5-star symbols for each field, and the script will run every minute. If 1 hour is 60 minutes, you can expect this script to run 60 times per hour. If you enter the following in Chrome tab, the specified script file will be executed every 10 minutes. So, you will run a total of 6 runs per hour. The run interval is also 10 minutes. Assuming you type the following in Chrome tab, the script you specify will run every 10 minutes. So, this script you want will run 24 times a day, 24 hours a day, because this script runs every 10 minutes every hour. If you enter the following in the Chrome tab, the script will run at 1:10 on December 1st. So, the script you specify will only run once a year. If you enter the following, it will run every Monday at 1:10. Of the 5 intervals marked with asterisks, the last field 1, marked with comma 4, is the part where the day of the week comes, and Monday is marked as 1, Tuesday is marked as 2, and so on. In the current usage example, the script is expected to run at 1:10 on Monday and Thursday. You can also define the period of the week. If you want to repeat from Monday to Friday, you can use the hyphen symbol as follows. If you wish to check what you have set in Chrome tab, you can do so using the Chrome tab add option. Since there are no current settings, the contents will not be visible. Save it and see the result. Enter the following and save. And if you print it using the Chrome tab add option, you can check the currently entered information without using an editor. This script will run at any time you want.